those days really. I take this opportunity to thank all those faculty members who taught me and who guided me and who molded my career in a beautiful way. Thank you very much. I would like to name some of the faculty members, like Biradar sir, who taught me mathematics in those days. I heard he has passed away. I'm really sorry for that. And Murthy sir, who taught me physics. And then Gurraj sir was there, who took mechanical subjects as well as engineering graphics, that is a drawing subject. And then Subbarao sir and Saraswati madam of triple E departments, whom I can't forget. They are the best. They guided us really excellently. They are, at the time, they were very young faculty members who used to mix with all the students and who guided us really in a beautiful way. I also take privilege to thank Dr. Deshpande, electronic faculty member in those days, as well as Agarwal, Professor Agarwal, who completely took all the computer science subjects and who guided clearly. So in those days, it was very tough because ours was the second batch of Gulbarga University in computer science division, and really excellent activity what we have received. Thank you very much for giving me such great, wonderful opportunity for me. Now I would like to share the presentation and then we'll start the work. Today's session is mainly with the supervised learning. So I'll be taking you means a small tour along with the activities of supervised learning concepts I'll be explaining. Okay, so this I feel it will just give you some brief idea, small idea how to go ahead in learning the machine learning concepts and supervised learning concepts and how to proceed your lifestyle. In case if you are planning for any future postdoctorate or doctorate degrees also, then this particular area of work is really is going to be wonderful. You can plan accordingly. Now, coming down to supervised learning, where when we are looking after the supervised learning, okay. Now, before starting, I would like to say one thing. If you are having any query, you can place it in the chat box so that at the end of the session, I can talk to you. Or if you want to stop somewhere and if you want to ask me, just definitely you can use mic and ask me. There's no problem at all. Please, so that we won't skip the points. If you feel that there is a important point which you are skipping or which I'm skipping or you're having any confusion, you can ask me at any time. There is no issue at all. Okay, fine. Coming down to supervised learning. Before that, let's look after machine learning concepts. Now, whatever we are doing, this particular job, it is online session. Okay, it's a wonderful activity. We are transferring the data from. I'm sitting in Hyderabad. I'm transferring the data. It's reaching to Bidar across Gulbarga University, where various faculty members and many other people are receiving. Okay, so that means what we are doing, we are using machine learning technology. Without that, we can't do. Even telephones, smartphones we are using. Early morning when we start, we immediately open our switch on the phone and then we start browsing. Oh, who has sent a message to me, WhatsApp group, okay, social media, that is and if if you forget something, if your wife or your any spouse says, okay, you did not bring me a book or you did not give me a pen or something like that, if some complaint is there, immediately we open the e-commerce materials and we start ordering, because nowadays many e-commerce services are available which gives you any material in less than 1 hour. So early morning, if your daughter or son says that you did not get me a book, I want immediately a mathematics book, there's no need for us to run around the shops. Just order it online. By 7:30, 8 o'clock, they'll deliver in your house and it will be fine. You can give it to your son or daughter. That means we are adjusted so badly we are right now with smartphones. This technology, I can say, everything is machine learning. Everything is machine learning. When you are ordering food, yes, it is based on the neural networks only. So machine learning is making or playing a major role in our area, in our life. Okay, so we have to be more careful in that. Okay, then coming out, what exactly machine learning is? An artificial branch. Okay, so artificial intelligence and computer science branch, it is going to be machine learning. It's a part. And here I would like to point out one interesting part. In my final year in 1991, when I delivered my seminar in my college, the first seminar it was in my college, and it was on artificial intelligence only. And second seminar, once again, I'm giving in this college as a faculty development program that is related to my artificial intelligence area. So really, I'm proud for that. I don't know how it is connected, but somehow it is connected to me with this college, with this particular area of interest. Okay, so really, this particular area of work is really interesting part. Okay, so as, now what exactly you're going to do? You are training the machine. Really speaking, it's a machine, electronic machine. You're training the machine so that it can teach itself. That means you're providing all the information, a set of algorithms, data, everything, and you are making it to learn, imitate how a human being learns the things. So machine is going to behave as a human being with the help of this artificial intelligence area, for which you are applying the machine learning concepts. So that is nothing but machine learning concepts. So you are developing the algorithms for that. So it is nothing but your machine is communicating as if a human being. So mm, pardon, someone is asking. I can't hear.
No, sir, you can continue, please.
Okay, fine. So what do we need? As I said to you, yes, machine learning concepts. Why? We are having already C program, C++ program, Java. So many programming languages are there. Why once again to think about machine learning or artificial intelligence or in depth of some uh, if then else rules, listing concept, all this. Why do we want? Why can't we go with C language only? Why, when we are learning the in the basic C language, why can't we use it completely? It's a traditional program. So, but what is happening here in in this digital world? We are having a lot of abundant data is available. Lot of data is really available, and this data can't be manipulated or can't be analyzed. It can't be digged out with the traditional programs, whatever we are having. Okay, so that is the reason we are supposed to go with the machine learning concepts where we are having multiple layers of the work, and it allows us to think in depth about that particular activity, how to go ahead and how to overcome the complexity. Okay, but when we are using the traditional programs, so if I want to update the data of the existing, yes, definitely it's going to be a messy concept, and it's going to be complicated, I can say. We may have to rewrite the complete application. Okay, so that is the reason it's always good to go with machine learning concepts. One more example, if I'm taking up, like nowadays, online, you are opening a Google internet concept, or let's say Amazon, you are opening. In the Amazon, when you start looking for orders, what will happen? It will fetch you all the old orders, whatever you have ordered. Okay, sometimes if you are not opening the orders and you are trying to search, it will say, okay, these are the small items which you have already selected or which you have already seen. So that means when you are typing the word, it is showing what we have done already. So that particular information is already coming up from where? It is through your programs only. These programs at layered steps, at a number of steps, it is understanding our needs. Okay, they are in number of steps. First time when you are looking, you are looking for a certain amount of data. Second time, other data. Now these algorithms are analyzing and overcoming the shortcomings, and they are projecting what exactly we are looking. Okay, now first thing what we must look after, how many ways are there to learn? As a human being, if I am a student, how many ways are there to learn the system? based on which I can think about a machine learning, how it is going to, how a machine can go for learning. So there are basically, if I say, there are 14 different ways of learning. Being any student, you are supposed to understand. If you are a student, you are supposed to know many of these things we are doing. And one more question I would like to place, and please answer this question through chat box. I'll look into that. It's only for you. Okay. So I said to you in the beginning, I was a student in Guru Nanak Dev Engineering College, and many faculty members like Subbarao sir, Saraswati madam, and Agarwal sir, they have taught me a lot of information. Now my question is, even you might be, you are a faculty member, you people are also teaching many things to your student. Now, in which category that learning mechanism lies here? Here, I'm giving you 14 different ways. Now, I identify in which category your teaching mechanism comes into picture. So let me look after the first thing, learning problem. Based on the learning problems, like you'll be having the solutions, supervised learning, unsupervised learning, reinforcement learning. Now, elaborately, we are going to discuss these things anyway. Okay, then hybrid learning, semi-supervised learning, self-supervised learning, multi-instance learning. I won't be discussing the other things. The first three, I'll be little bit, I'll explain definitely. Okay, supervised learning. Now, that is the area of work what we are going to today's session completely going to be. Then unsupervised and reinforcement learning. Yes, little bit I'll be explaining about that. Whereas semi-supervised, it is a hybrid concept of supervised and unsupervised concept. Self-supervised, it's one who takes care of himself for understanding, for learning the things. That is semi-supervised. Multi-instance, yes, multiple activities, multiple ways of uh, understanding the problem. It is going to be multi-instance concept. Then statistical inference. So like you are having inductive learning, deductive learning, transductive learning. I don't want to explain because it's well known to you people, because normally in our classroom we are implementing. Okay, inductive, normally it says that whenever a new activity, for example, right now you are learning about supervised learning, feeling that it's a new, okay, you are learning. That is the inductive. Deductive, as facts I'm teaching and you are learning, that is what is going to be the deductive. Transductive, yes, you are making some mistakes, and through the mistakes you are learning that activity. And that is nothing but through observation. You are observing what is happening. Okay, and you are saying that, okay, this mistake I should not do. I should observe carefully when I'm doing, and I should consider. That is what is going to be the transductive learning concepts. Multitask, multiple tasks parallelly you will be learning. Okay, for example, you might be a PG student, MTech student, or you might be a PhD scholar working in watermarking area or image processing area. Parallelly, you are teaching machine learning to your students. Okay, fine. Parallel multitasking activity. So definitely you are welcome for that. Then active learning. Yes, that is very interesting part of the work. Okay, so do we have inactive learning concept? Always you have to question yourself. Active learning, yes, many things which are inland. I want to work. Okay, so I'm looking after. Uh, I I'm having practical. Okay, practical work. I'm looking after. That is also active learning concept. Online learning. Okay, as I said, huge amount of data is available online. Okay, you are supposed to gather. Okay, is it feasible to me? Is it required to me? Read it. So that is online learning. You will be learning. Okay. There's a question. Okay. Just we'll be coming back to the chat box afterwards. Online learning, fine. Transfer learn, transferring, sharing the information from one part to other. Okay. As a faculty member, I am sharing the information to you, and you are receiving the knowledge completely, and you are the. So here, while transferring, what exactly is going to happen? I'm transferring. So you are, as it is, you are applying the technology. Ensemble. Ensemble, what do you mean by ensemble learning? Ensemble means you are deploying some models, and those models you are applying for the data, upcoming data, new information you are gathering. Okay, you are whatever the model is applied, that for that you are applying. Okay, so this is going to be, I think um, some faculty has asked inductive and transductive learning, I think so. I can't see that. Okay, anyway, we'll look after that particular person. Before that, unsupervised machine learning concept. I'm not starting with the supervised learning because it is our area of work. Right now, we are going to conduct the session. So just overview, I want to give about a brief information about unsupervised learning. Okay, so here, this machine learning technique, it analyzes. Okay, so what it is doing? It is analyzing the part and cluster unlabeled data sets. Okay, it is analyzing and clustering unlabeled. Now, the question comes up, what do you mean by data set and what is unlabeled concept? How and what exactly is going to happen? This, when we are discussing this, when I discuss about supervised concept, there automatically will come into picture. Okay, so the first thing is, please do remember this particular word so that when we start working with supervised learning, you will understand. Reinforcement learning. Okay, here the reinforcement learning is mainly to apply the learning technique based on the mistakes. You are doing some mistake. Okay, you understood it's a mistake. So what you are doing, you are not going to do that particular mistake in your lifetime. At the age of 20, you felt that you did a mistake. At the age of 60, will you repeat the same? No. Why? Because you know it's a mistake. You know it's going to be a mistake. Okay. So for example, today you're going on in a particular path, and you felt that's the wrong route. Next day also, will you go in the same wrong route? No, because you understood, okay, this is a mistake, and we should not go in this direction. It's a wrong path for me. Okay, that is learning the things from the mistakes. That is what is the reinforcement. Now, coming down to supervised machine learning and unsupervised machine learning, what exactly? Let's look after. As, let's learn this particular work through a simple example. Let me give you a simple example first, and then we'll go with the work. Okay. In every city, you will find some street with heavy traffic. Okay, some street, some area, it is with heavy traffic. Now, the question is, what do you mean by traffic? It can be vehicle, it can be public, it can be some animals, it can be some other way of your thinking. Heavy traffic, we can't means if there are 1,000 people in a particular street, it's purely a market. Let us say market is said to be heavy traffic when more public are inside. Okay, so you are counting only public. What about the vehicles? You are saying not. Why? Because vehicles are not permitted inside the market, so vehicles are not countable. You are counting only the public. So likewise, whatever the data you are gathering about that particular area, that is going to be part of your data set. Now, whatever the data with which you want to analyze the things, you want to say something, then that data is going to be labeled. Fine. Like public, you are saying so much of public rush is there. People are coming in and going out. So you are labeling that particular data as people. That labeling, these labeled data is countable for understanding the traffic in the market as part of your supervised learning. Now I say the other way around. Okay, your market is busy, you're having so much of public, fine, but the other way around, there are no public, but still the market is packed, the market is full. How come, sir? It's just think, early in the morning at 4 o'clock or 3 o'clock, all the lorries, the trucks will come to dump the goods in the market. Okay, so early in the morning when you look after, the trucks are parked outside the market, but they are not coming inside the market. So fine, there is no concept. But all the coolies, they are bringing the luggage. The number of coolies, the weightlifters, if you are looking after, they are very few. They can't be compared with the public who are purchasing the are moving inside the market at all. They can't be compared. The number is very less, but still you can't even step into the market. Why? So many goods will be coming in and they will be parked, they will be placed inside, and market is completely full. Early in the morning at 6 o'clock, when you go inside, you can't step into the market. Can you say it's a heavy traffic? No. But still, what is happening? You can't get inside. So here what is happening? The goods, whatever you are having, they are unlabeled. They are not considered for saying traffic area. But they are affecting the performance of the market. So unlabeled structural work, whenever you are considering, that is based on your unsupervised machine learning concepts. So that is a basic area of difference, what we can say. Now coming down to the supervised, once again, definition, exact definition, if you are looking after, it is to use the labeled data sets. As I said, the label is people. Labeled data set to train the algorithm. So based on that number of public and other, you are training the algorithm. Okay, at 6 o'clock, 10 people are coming, so it is not traffic area. At 6:30, there are 1,000. Yes, it is traffic. At 7 o'clock, there are 10,000. It is more crowded. The market is heavily crowded. Okay. So likewise, you are training that particular algorithm. Now the algorithm is ready. Once the algorithm is ready on a particular fine morning, you want to check whether the algorithm is working perfectly or not. Okay. This is going to. So here what is happening? At first, with the known values, with the known activities, you are providing the data set and labeled information for your system, and your algorithm are developed and they are tested for the known values. After that, yes, you are applying for unknown and you are trying to identify. The other example also, let's look after. For the last 50, 60 years, the weather forecast is already available with our geology departments. Geological departments, what they are doing, they are analyzing it. Okay, if the cloud is dark black, then they can expect heavy rains. If it is moderate, then they might be expecting little less. Okay, if it is white, then they can't expect rain at all in that particular area. Okay, that is one labeled data set what they are counting. The other label also, if you are looking after the wind speed. Okay, the dark black clouds are there, wind is with heavy speed, and temperatures on the ground, they are very low. So accordingly, the rain is going to be calculated. So these are all the labeled data set what you are having. Now, once if you are calculating and if you are measuring, if you are executing, okay, you are applying on the known values. Then for future, you can apply. You can say it is going to be more or less one is the same. That's what happened in recent days. If you are looking at the geological department, they are forecasting, saying that heavy rains are going to come up in Chennai, Hyderabad. They forecasted, and almost the same as up pointed out. Okay, so that is machine learning concept only. There is nothing but machine learning concept. You are labeling the data, you are training the algorithm, you are testing on the known values, and you are applying. Okay, so that is what is going to be. So what is happening? If any mistake is there, you are going to rectify that. Once the model is ready, yes, my model is ready. Black, dark black, okay, medium, whatever the model I'm having, all the variables, all the values. Once if I'm defining for my cloud for to identify to forecast the rains, yes, my model is ready. Now when the cloud comes up, I'm going to compare which part of the model it is going to lie. Is it a dark black or is it a black? It is moderate. So I'm adjusting the model according to the requirement. And then I'm going to discuss, okay, this is going to be the forecast, accurate results are going to be. Then definitely my accurate results are going to come up. Now, when I'm inserting the parameters into the algorithm, yes, they should not be overcrowded. They should not be overfitted or underfitted. What do you mean by that? More number of parameters if I'm taking, it's going to be very, very worse. For example, in the classroom, there are 60 students. I want to identify the intelligence levels of all the 60 students with parameters. Now, what are the parameters? As a faculty members with 25 years of teaching experience, if I start analyzing, saying that hundreds of parameters, like the student is regular, the student is disciplined, the student is wearing a very good dress, and his haircut is good, and his PhD uh, expression is good, everything, if I am counting, then it is going to be overfitted. I may not judge properly. Why? Few students are really excellent who work whole night and just they wake up and come down to the classroom to listen to the lecture. That means they are not properly dressed. Now, can I say they are just because they are not properly dressed, they are not intelligent enough? I can't say. So those things sometimes they are going to be problem. Now, underfitting, if I am looking after very few parameters, if I am counting, like only the marks. External examination, whoever gets 70%, they are the intelligent people. And if a company recruit only those 70% or 80% students, will they be successful? No. That is the reason they are conducting an interview. Okay. So parameters, if they are less, that is going to be another problem. But if the parameters are more, that is going to be another problem. We are supposed to fit perfectly that particular activity. So supervised learning helps the organizations solve real-time, real-world applications. Even you can look after your spam in your email when you are receiving so many mails. If you are not accessing mail which is coming from a particular person continuously, then automatically that new mail, whatever comes from that particular person, will be pushed into spam automatically. Okay, so that is understandability. That is by learning. So machine is learning that particular activity. Now, how to solve any problem? If any problem is given, how to solve that particular problem? In machine learning concepts, when I'm looking after, yes, UC Berkeley has already defined the way to solve a problem. First thing is a decision process. What you're going to do, you're going to predict or classify the information by using the machine learning algorithms. That means the machine learning algorithms are basically used. Okay, what am I going to do? Am I going to get heavy rains? That is the prediction. Or classifying, okay, he is intelligent student or he is non, he is moderate. That is another prediction, another activity what I can do with the supervised learning without any problem. And based on what am I doing this? Based on the input data. I'm giving input data. Now, based on the input data, how am I going to do? I'm comparing with the previous examples, already understandable concepts. So my learning mechanism is based on existing information with me. I'm supervising, I'm just observing carefully, I'm comparing the things, and then I'm deciding, okay, this is what is going to happen. This is what I'm, for example, just let's go look after the olden days activity, pharmacy, or our astrology. When you look after how our pundits have calculated your age and your behavior, everything, it was not discussed at the time how it was happened. But now, after learning all these things, you can say, yes, palmistry is part of the machine learning concepts only. What they have done, they have analyzed number of people with the same structure. And then they decided, okay, if this line is in this way, then this particular things may happen. That is the analysis. Okay, few lines are identifiable based on which the information is well discussed. So now you can sit and you can write a beautiful pharmacy application, which is part of your supervised learning, machine learning concept without any problem. Then the second one is an error function. As I said to you, pharmacy, you are taking care. If in the line, if there is a break, that means there is a small error what you did not consider. Because of the break, the person's something may happen. So I analyze, and then you decide the work. Yes, can you hear me? Am I audible?
Yes, sir, you are audible.
Yeah. So am I going fast?
No, sir, with good pace.
Is okay?
No issues.
Yeah. Okay. So there is a mistake. You did not count that particular break in the palm. Okay. Now let's go with the other example also, which is well known to us. In a street, you are saying that okay, it is well traffic area. Now, in that particular street, at what time the traffic is going to be high, at what time the traffic is going to be low, at what time the traffic is going to be moderate. As I said in the beginning, based on what you're going to say that it is traffic area, based on number of people, the count, like 200 or 300 or 500 or 1000 at a time, people will be rushing in. So the street is traffic. Are you going to say that? Or based on two-wheelers, like at early morning, at that time, because of the students area, all the students will rush up with their bikes. So are you going to say just because of the two-wheelers, or based on the four-wheelers, or based on the heavy traffic vehicles, like early morning or afternoons times, the trucks are coming into that street, that's why it is traffic area. So that means all these data, whatever you are having, you are supposed to label. Now based on these four items, one is people, one is two-wheeler, third one is four-wheelers, small vehicle, small or mini four-wheelers, and trucks, I'm counting. Based on these four, normally people will say that based on four, the traffic is going to be identified. Fine. Now the error is, if there occurs a, means you are saying that there is no traffic, fine. In that particular street, there won't be any time, there won't be any traffic at all. But let us say all of a sudden there is an accident and someone unfortunately lying on the road. What happens? All the vehicles on both sides, they will be stopped because person is lying on the road. When all the vehicles are stopped, what happens? Traffic will be more. When people are gathering and when they are on the road, yes, the street is crowded. Now, can I say it is traffic area? Yes. Why I could not identify that traffic? Because I did not label that accident. I was not aware of that. I'm not counting that. Fine. What happens? That is an error. According to my algorithm, I said there won't be any traffic at a particular point of time in that particular street. But what has happened? That street was traffic fully. Why? Just because of a mistake. That is an accident. Now, can I consider that mistake or an error, that accident concept, for the rest of the time also? That depends. Why? Accidents won't occur every day, every minute, every hour. Now, to be counted or not to be counted. So that is what is going to be the supervised learning basic idea. Once if you are not defining properly, your algorithm is going to fail. Your algorithm is going to fail. So definitely you are supposed to. If there are known examples, yes. If the error is well defined, you're you are supposed to consider the accidents, yes. Automatically algorithm is going to function excellently. If you are not defining, your algorithm may fail, and definitely it is going to be a failure. The algorithm automatically fails. Now, optimization technique. That is the third part of the work. You are dividing the complete problem into three parts. The first one is the decision, second is the error, and the last one is the optimization. In the optimization, as I said, okay, cloud example we have taken, raining example we have taken. Dark cloud and black cloud. Clouds are there, black cloud and dark cloud. What is the difference? That depends on the programmer. As I am defining, something is very black and something is very dark, that is of mine. So when I'm using, I must be confident for using. I should not make a mistake when I'm applying for a new data. Okay, there the optimization rules occurs. 90%, 99%, 99.9%, 95.7%. All these things are to be calculated strictly so that I can optimize my information so that my performance is going to be extraordinary. For example, the other day, last 2 months back, if you see in Hyderabad, weather forecasting, on a fine morning, GHMC has announced, or the other way I can say, Geology Department has announced that it is going to be heavy rain on on this particular day. And even the government has announced the holiday for Hyderabad people. What has happened on that particular day? Very normal rain was there. It's not heavy at all. The correction has come up saying that, okay, wind direction has changed, so clouds moved out and there is no rain at all. Why didn't the department consider that particular wind direction spot also? So that is going to be the optimization part. If you are not optimizing the algorithm properly, definitely it is going to be a failure. How this particular model going to work when I'm working out? Models are trained first. You are going to train the data sets. Okay, then they are going to understand. Okay, algorithms are going to understand. This is going to, for example, if I say this is supervised learning, then you will feel that it is a supervised learning. And tomorrow, if someone else says that unlabeled data sets are considered trained for supervised learning, then the question will come. Sir said already supervised learning means labeled data sets. Now the other party is saying that unlabeled data set. Which one is correct? You are going to define with your brain saying that, okay, I already read in a book that it is labeled data set only considered for supervised learning. Then what happens? The new lecture, whatever is coming up, it is faulty. So that is how you are training your brain and you are deciding what is correct and what is not. In the same way, your machine is trained. And now, whenever you are giving a new input, it will decide whether it is correct or not, whether it is true or false, whether it is acceptable or not, what is predictable data, everything it is going to do. In all these cases, what is considered? It is considering only the labeled data. It is not considering unknown data, unlabeled data at all. Okay, so that is what is the important activity. Once the training process is completed, the model is tested first on the existing available data, and it will be compared with available output, that is the results. After that only it will be applied on a new work. So the basic steps involves, what are the steps involved? One by one, if you are looking after. First step is the type of training examples. What is that example you are having? You are supposed to identify thoroughly. If, let us say, in the classroom, I want to say one student is intelligent. Okay, based on what I'm going to say, he is intelligent. I must know. Okay, based on above 90% attendance, he is said to be intelligent. Fine, that is a trained example. Now I'm asking the student to write the exam, and if he is getting above 90%, he is said to be an intelligent person. Okay, now out of the classroom, no one has achieved 90%, but one student is achieving 70%. He's the only student who got 70%, rest got less than 70%. Now, can I say he is intelligent or not? That example must be available. If I'm having only that particular class and the student's capacity is 70% only, the maximum capacity, can't I say that student is intelligent? So here, the same application must be given even for your computer also, based on the situation, based on the environment. If you are not defining properly, your machine will say he is not intelligent at all. But as a human being, when I go into the classroom and if my class is like that, I'll say 70% student is intelligent student when compared to others. But if I'm not defining properly and if I'm not training my data set properly, my machine won't do that particular job at all. So the examples are very, very important for me when I'm training that particular algorithm. Before doing anything, the user should decide what kind of data is to be used, as I said to you. Now, other example I gave you here, handwriting analysis. Nowadays, just take a notepad and start writing. Immediately that can be transferred onto your computer set, WordPad. Okay, so whiteboards are available. You just take down the whiteboard and use a marker and write it onto the whiteboard. Automatically, the data will be stored into the computer. Fine. How is it? My handwriting must be understandable to the computer. Why? Just observe carefully. If you are a doctor, not a PhD doctor, I'm telling a doctor, MBBS doctor. Or let's consider their medical prescriptions. Can you read that medical prescription easily? Not possible at all. That medical prescription is understandable only to the medical store. No one else can understand properly. That is the reason nowadays Supreme Court has given a direction saying that all the medical prescriptions must have only uppercase letters, not cursive handwriting. Okay, so that handwriting must be given and it should be tested. And yes, once if you are testing, you will understand where is the mistake. When you correct, automatically computer will understand the mistakes. Based on the complete information, the label data will be ready. Now, next time when you are writing the prescription, automatically computer will understand and it will give you the information perfectly without any problem. So the next step is gather the training set, gather all the information. Then training set needs to be real-time application. You are going to check out the presentation. Whatever the training set you're gathering, it should be proper. It should be identifiable. Okay, so you are going to check. That is what is the human expert verification. Next step it is going to be. Determine the input features. So perfectly you are supposed to, as I said to you in the traffic, you are supposed to identify the input features. Like I said, your people who are walking in the street, vehicles who are driving, like a two-wheeler, four-wheeler, or truck. Okay, all these you are identifying. What about the animals? Foreign countries software, when you are looking after, they won't think about animals on the street. But in India, animals must be counted because you will find many animals crossing the street all of a sudden. Okay, so that is also to be labeled properly. The accuracy of the learn function depends strongly on how the input object is represented. The accuracy is definitely it is going to be dependent on how. So in the supervised learning, you are supposed to identify the parameter perfectly. If you are identifying the input properly, then definitely it is going to be excellent. Otherwise, and all this information is going to be placed into the vector. Now this vector format you are going to look after. If the vector size is too much, then what will happen? Overfitting will come. If the vector size is very small, underfitting will come. So you must identify the parameters according to the requirement and which are more effective, and you must consider. So the number of features should not be too large and should not be too less also. Determine the structure of learned function and corresponding learning algorithm. So you are going to determine and then complete the design. Run the learning algorithm on the gathered data. So your work is done. You're gathering all the information, you are labeling all of them, and you are identifying the suitable algorithm for that, and then you are running and you are now getting the results. So these results are to be compared with the existing results. If any fault is there, you are supposed to adjust the parameters and then you run the things, and then yes, the model is ready for you. This is the way you are going to develop the algorithm for supervised machine learning concepts. Okay, so for example, one more example here I am showing you. You are having the labels. Okay, so hexagon, square, triangle, all these are well defined before only. I have taken all the information and I just tried with, and information is ready for me. The new set I'm giving for that, for my machine, for prediction. Now, the information, whatever the training has already done, that algorithm, with the help of that particular results and other information, it will test the data and it will say whether it is a square or a triangle. So your algorithm is doing that particular basic job. Now, how these algorithms performance is going to be affected? The basic parameters when you are looking after. Do we have any bad effects? Yes, definitely it is. Being a human being, if you are making a mistake, then why not a machine makes a mistake? Because that is learning by us only. If you are giving perfect activity, definitely machine is going to be perfect, 100%. Even if you may make a mistake afterwards, but the machine won't, because it will follow strictly the rules. Now, what are the things? The first thing is bias variance trade-off. Yeah, we are going to discuss. Just I will give uh, the works. Okay. The section is up to 11 o'clock, so it's 11 up to 10:45. I'll take up, and then the questions I'll be discussing. Do you have any question as of now, which is to be addressed quickly? Yeah. Any important? There is a question actually. Is Sujay? He has asked, I think, inductive learning versus deductive learning. Okay, so inductive, I said new variables, whatever you are receiving, new examples based on that, the learning concepts is always dependent. Deductive, yes, the facts you are defining. Okay, the facts. For example, right now, whatever I say, it is fact. It is from the textbook. It can't be modified. It based on the fact you are learning something. That is what is the inductive and deductive. What is inductive learning? Can you elaborate with it with example? That's what I did for Sujay. And yeah, these are the questions what I received as of now. Fine. Let's go through the parameters affecting the supervised learning. The first one is bias variance trade-off. Okay. Yes. Being a human being, for example, in the traffic, the street is very big. It is four lane, as let's say at junction. In such a big junction, if I'm having 100 people, I may not count that number because the heads, the people, that is acceptable. At the same junction, if there are 2,000 people standing over there, then I may have to consider as yes, it is crowded. It is crowded. Now, at the same time, if there are two animals, can I say it is crowded? No. But can I say they won't be affecting my traffic? I can't say. Why? Because if those animals sits in the middle of the road, they won't listen to the vehicles. They won't care about the people nowadays. Unless you take a stick and run behind, it won't go out of that. So what is happening? It is affecting your, but what you are doing, you are neglecting. Being a programmer, you are neglecting. If the same job is assigned, if the calculation job is assigned to a foreigner, saying that, okay, I want prediction, traffic prediction in this Hyderabad city, US developer, what he will do, he will develop a product excellently and he will implement in India. Definitely it is going to fail. The only reason is here, the animal concept, the problem. Why? Because you are giving some bias, that giving some negligence concepts. For example, in your classroom, when you are correcting the papers, first time if you are correcting the paper, first time you are teaching in the classroom, and then you are correcting the internal marks, internal papers, answer booklets, you'll be very, very strict. You won't care who is studying, who is not studying. You will just cross check, and you will quickly identify who has copied, and you will cut down the marks. Strict. The After 5 years, you'll start thinking, okay, they are students. If I start cutting down, they are not getting marks. And once again, management may ask me, or parents may come up and ask me why the student is not getting marks. They may feel that I'm not fulfilling my job properly. After 10 years, you'll say, what the hell? If parent comes up, I'll say, there is no problem. I am going to be very strict. I won't listen to anyone. Because you are changing. According to you are doing the corrections properly. But what about computer? If the same concept to be given, it is not going to do the bias concept. It won't care who is thinking what. Okay, so that bias, yes, it is going to affect the performance of your algorithm all the time. You must be more careful about that. Then function complexity and amount of training data. The function complexity. Now, the traffic only, if I'm taking, uh, the traffic is less, okay, according to me, when I'm counting only the two-wheelers and four-wheelers. Because regular traffic in that street is only with the two-wheelers and normal four-wheelers like cars and jeeps, nothing more than that. But all of a sudden, if trucks comes into picture, just because uh, it is afternoon time or evening time, the city commissioner has allowed the trucks to come into the city. So all the heavy load vehicles they are coming into the street. Now I'm going to count those types of heavy vehicles. There will be four wheel drive is also there, 16 wheel drive is also there, or some other concepts. Am I going to look after all these functionality? That is first question. Second is okay, two wheeler. Am I going to count even the cycles also? Okay, people. I mean, am I going to count people like adults and children and male, female, and other? Is it possible? So that means I'm fixing myself in a complex way. When I'm considering, the complexity of the function is increasing. When the complexity of the function is increasing, the performance definitely it is going to degrade. It will go down. Now, if I am not counting, let us say only adults are counted, not the children. And a fine morning, like let's say at 9 o'clock or 8 o'clock, school time is there. All the children comes onto the road. Because in my algorithm, I did not count the children. What may happen? My algorithm fails. The performance is bad. Why? Because the children are not counted. The traffic is set to be normal, but due to the children, the traffic is heavy. So the traffic effectiveness is to be counted. So the function complexity is going to be. And amount of training data. Okay, in school area, you are counting the children. Do you think every day the school will function? No. Holidays are more. During the holidays, if you are not counting, fine. What will happen? The algorithm is going to fail. Because on a fine morning, one wants to travel in that particular area, and you said your computer is stating that that area is going to be heavy traffic. Heavily, it is congested area. Don't go in that area. But on that particular day, it is a holiday for the schools, and traffic is very clear. It happens nowadays with your Google Maps. Just check it out. Try once. Identify the direction in which you want to travel. Mark it. Say that in Google Maps. Say from your location you want to go to a certain location. Sometimes what will happen? The Google Map will drive you to a narrow street where your vehicle can't go inside at all. Even one or two cases are there where the Google Map shows for the people to walk into the houses also, saying that is a road. Where is that? It is basic functionality complexity problem. You have not counted biased, and you have not counted, you have not trained the things properly. You have not trained the thing. That's what I can say. The vehicle is not moved in that direction, and you did not move the vehicle, and you did not consider the value, and you did not train your Google. That is the reason Google is showing that narrow lanes for driving. So that is the effectiveness. Then dimensionality of the input. Yeah, dimensions. That means how many parameters you are considering, and each parameter at a particular stage, it is providing some input. It is going to affect that particular quality of the work. So are you considering every parameter's dimension properly? The area of work, the angle of effectiveness, are you calculating properly? Okay, if then let us say at one particular junction, the number on a fine morning, the number of children crossing the street are more. On a fine morning, the number of children crossing the street are more. Then you can say it is a heavily traffic, congested area. Now, after 9 o'clock, there is no child crossing the road, walking in the street. Can I say it is not congested? Maybe, may not be. If I'm not considering the other parameters. Okay, so the input parameter is always valuable. As I said to you, the animals. Okay, so you are supposed to. Then noise in the output values. What do you mean by that? As I said to you, the rainfall is there. You have calculated the rainfall on a fine morning. You are saying, you are announcing that there will be heavy rain in that particular area, like 24 centimeters or 30 centimeters heavy rainfall in the city, and city can't bear that. City can't bear that. Fine. You have predicted based on the previous earlier values, and all the input whatever you have given, it is correct. It is perfectly correct. But all of a sudden, due to some environmental activity, the rain is not up to the mark. Now, what is happening over there? Let's say the wind direction has changed, and all the clouds have moved out of the city. And instead of within the city, the rain has fallen out of the city. Or let us say nowadays people, even our scientists are doing some special activity, I can say. Uh, for example, COVID only. Simple. COVID virus. They are calculating through computer only. They are not doing something outside. What are they doing? They are taking the RNA analysis, whatever the architecture they are having, they are feeding to the computer. Now they are calculating, okay, this if this structure is there, this is going to be a medicinal activity. The chemicals are mixed, and the chemical mixture is also, the architecture is also defined or designed through computer only, and it is feeded. Now the computer is giving the results saying that, okay, uh, a particular composition of the chemicals will destroy the RNA architecture. Now, based on that composition, our scientists are developing that particular composition, and they are delivering the. Now, are we getting the result exactly? 100% we are not getting. There is some noise, there is some deviation. When that medicine is given to the people, 90% or 95% are perfect, there is no problem. The rest 5%, yes, they are failed. Either they are getting side effects, or they are getting some unknown activities, or they might be dying. That is nothing but your noise. That is nothing but your noise. You are supposed to minimize that. Early days of the COVID virus vaccination, like your Covaxin, they found number of side effects. Step by step, they have reduced that side effect. Step by step, they have reduced. Now, even they are saying that Covaxin, yesterday they have announced that there is no need of using paracetamol after Covaxin vaccination. That means step by step, the noise levels they have considered, and then they uh, means they once again trained the data set, and then based on that, the new results are obtained, and the new composition have generated, and noise is reduced. Noise is reduced. Okay. Now coming down to the other side effects, heterogeneity of the data. Heterogeneity, homogeneity, and heterogeneity. The data is in dissimilar ways. Whatever you are discussing, it may not suit. You are saying traffic in one area, okay, traffic in one area, fine. But the same algorithm, can I apply in a colony? Can I have the traffic in that colony? No. So for that, the algorithm, if I'm applying into some other traffic areas, it may not be suitable at all. Traffic inside the temple, whatever I'm having, is it the same in traffic in market? May not be. Or traffic in the mall? No, may not be. So algorithms may not match. That depends on the data or whatever you are applying. Redundancy in the data. I said adults, male, female, children, boys, girls. And let us say inside the computer, you are thinking about the traffic. No, why can't I insert all these male, female, boys, and girls as a single unit of people? Why should I separate individually when I'm counting about the traffic? So that is another problem. What people or the programmers will do is a common mistake. You are supposed to take care as a programmer. If you are analyzing as a machine learning designer, if you are training your data set, you are supposed to consider that particular problem. Then presence of interactions and non-linearity. Whatever the feature you are having, if it is independent, all the features are independent, they are not dependent. Just imagine. For example, in this faculty development program, there are 20 people or 30 people, and no one accepts a particular point. Everyone is having their own interest. Just imagine. Can we come to the conclusion that it is the correct statement? No. When we are discussing and the statement, we are giving dimensionality, different ways of answer, not true or false. We are not discussing whether it is true or false. We are saying something is else. Everyone is accepting according to our interest. Then never the conclusion comes into picture. So this factor is to be considered, and it should be properly guided, trained to the data set. Then only it is acceptable, and our algorithm is going to be perfect. Then complex interactions among the features. There is no, really speaking here, there is no interaction between the faculty members. One side, I am teaching and you are listening continuously. Instead of that, if all the mics are on and if everyone starts saying something, everyone starts speaking, what will happen? It's not possible. You can't understand anything what is happening here. Okay, so that is going to be complex interaction. So coming down to the algorithm, basic algorithms. Under supervised learning, two types of algorithms can be applied based on the input. One is going to be regression, the other one is going to be classification. Which algorithm to be used? So here, regression algorithms are more suitable when the input data is having relationship among themselves. So the input variables, whatever you are using, if they are internally related, then regression algorithms are more suitable. For example, the rainfall. I am looking after only the rainfall. That is, there the clouds are there and the wind is there. So based on the wind, the rainfall, the cloud is going to move. Based on the wind direction, the cloud is going to move, and due to which the rain is going to be heavy or light, moderate, everything. So that means there is a relationship. Now, can I say my traffic is going to be heavy just because of the rain? And what type of rain? Even for the light rainfall also, there will be a traffic problem. Even for moderate also, there will be a traffic problem. Even for heavy rainfall also, there is a traffic problem. Why? When you set the rainfall is there, the traffic problem comes up. Then your algorithm always says for any sort of rain, it always says that traffic problem is there. The relationship, whatever you define, is very, very important. You are supposed to consider properly. It is used for the predictions of continuous variables. The other example is market trend. The market trend. Right now, share market, when you are looking after. Yes. Compare that, how the industry is moving, and based on the industry movement, the share value will be moving. If you are having the parameters, how the industry performance is affecting your share value, yes, that analysis is very important. Then only you will be investing, the people will be investing in the market. Otherwise, people can't invest in the share market at all. If the proper analysis is not there, and blindly if you are investing, and definitely you are going to fail. That means you are supposed to train the data set, the algorithm properly, when the share will rise and when it will fall down. If you are training the data, your algorithm is going to be perfect. So what are the most popular regression algorithms we are having here? Linear regression, regression trees, non-linear regression, Bayesian linear regression, polynomial regression. I don't want to discuss much of these things because all these algorithms, whatever are there, they are part of your data mining. Because data mining is a prerequisite to start learning with the machine learning concepts. So once if you are familiar with these data mining algorithms, everything, automatically you will understand it. So these are most favorable or most important algorithms under regression. Then comes up with the classification. All your output variables are categorical. There's only true or false. For every variable, you are having true or false values only. Rain occurs, yes. Why? It is cloud. Heavily cloud. That's it. When the heavy cloud is there, rain occurs. Otherwise, no rain. So yes or no concept. Class is there, yes. If college is working, class is there. Yes or no concept. For example, your device, whether it is functioning or not, how to test? First thing is, are you giving the power supply? Yes. Is your computer on? Yes. Has your hard disk received the power supply? Yes. Like that. If it is not receiving, then you will be testing whether the power supply is there or not. If failed, that means hard disk failed. Only two concepts, yes or no, yes or no. Okay, so some of the examples, algorithms when you are looking after spam filtering, random forest, decision trees, logistic regression, support vector machines. These are all basic concepts what you can apply. And most general applications, if you are looking after, yes, all these areas are acceptable. You can apply and start developing your own algorithm, supervised algorithm. Bioinformatics, yes, as I said to you, nowadays for COVID, we are doing the same job. Database marketing, we are doing the same job. For example, Amazon, you are typing something today and you are searching for something. Tomorrow, when you open and if you type the first three words, automatically it will show you what are the items you have seen already. It will say these are the items already you have seen. You have shortlisted. You have identified. All these information will be given to you. Handwriting recognition. Yes, there are some softwares which are available. Smart boards are available in various classrooms, in schools also. If you write automatically, for example, if you are not having, just go to any CBSE schools. Nowadays, they are maintaining one smart board. Then information extraction, object recognition. Yes, computer vision concept. Okay. Even our biometric attendance systems are there in most of the universities. When you are placing a thumb, you will be placing your thumb in different directions, but still it is adjusting and it is doing. So learning activity to be done. So that, then only it will be faster enough. Speech recognition. Yeah. Nowadays, in most of the computers or even in houses, you are having Alexa. You are saying, Alexa, please switch on the phone or please switch on the light. It is doing the job. Please play. It will play. So that is speech recognition. Landform classification, they are satellite activity, what we are doing. Now, coming down to the advantages, with the help of supervised learning, the model can predict the output on the basis of prior experiences. So here in the supervised learning, what is important? Based on the previous experiences, the output is dependent. If you are giving new things, sorry, because so experience is not there. My data set is not trained. Algorithm is prepared for traffic. And now if I am applying for traffic in a mall, now the question is, the algorithm, is it really workable? Why? Because the earlier algorithm, whatever I prepared for traffic in the street, now when I apply the same into the traffic in the mall, it is not acceptable because the vehicles are not there in the mall. So likewise, the by basis of prior experience only, it is workable. We can have an exact idea about the classes of objects. We'll be having exact idea what we are doing. And real-time world problems like fraud detection, spam filtering, everything, it is very quick and easy. This is going to be the major advantage with the supervised learning. Now, coming down to the disadvantages, as well as I can say even some of the challenges also. They are not suitable for handling complex tasks. I already said to you, complex activities. Let us say more than 10 variables are involved, applied in identifying a work. It's a complex. You can't do it. Okay. For example, a simple example, I want to apply this particular supervised algorithm for solving Kashmir problem. When can I say the Kashmir will have the solution? It's going to be a complex activity. I can't, because various factors are affecting. My algorithms are going to fail. Supervised learning cannot predict the correct output if the test data is different from the training data set. That's what I already said to you. The test data is traffic in the street, and the given data set is training data set is traffic in the mall. Both are different, and definitely the algorithm is going to fail. Training requires lots of computation time. You'll be spending more time only for training. After that only, you'll be bringing the algorithm into the market. So it is going to be very tough. In supervised learning, we need enough knowledge about the classes of object. So prior knowledge is very, very important if I want to take up the job. Learning models require certain levels of expertise. That's what I said. Without experience, if you are working, definitely algorithm is going to fail. Training supervised learning models can be very time consuming. That's what I said. Okay. So that is the basic challenge. Data sets can have higher likelihood of human error. All these are just because of human error. That's the first statement, what I said in the beginning. As a human being, whatever you do, that is what your machine is going to do. If you are making a mistake, your machine definitely is going to make a mistake. Okay. So because you are the programmer, depends on you, activity is going to be. Okay. It cannot, the supervised learning cannot classify the data on its own. It can't classify it, definitely. Whereas unsupervised learning, yes, it can classify. Certain data belongs to this, certain data. For example, if you are applying the unsupervised learning for classifying the metals and non-metals, it can quickly do it. But supervised learning can't do. So what are the points to remember in this particular session? All the data, whatever you are using for training the data sets, they are labeled. So that information you are supposed to remember. So it mainly helps you to predict how long it will take you to drive the home. So that is the best example what you can say. Okay, regression and classification are two dimensions of a supervised machine learning. So this is the other point to be remembered. Supervised learning is a simpler method, while unsupervised learning is a complex method. So supervised method, that's what we said. If the complexity increases, your supervised method cannot be applied. In the same way, supervised method always is going to be simple, whereas unsupervised method is always going to be a complex work. The biggest challenge in the supervised learning is irrelevant input feature present for training data. So irrelevant input data, if you are giving, you will be getting inaccurate results. Definitely they are going to be inaccurate. For measuring the rainfall, if I give the data of the traffic, that means number of people or number of houses in that particular area and the area covered, everything, it is no way it is going to, because it is incorrect data what I'm providing. For calculating the rainfall, why houses are to be considered? I want only the area, number of kilometers or number of meters, how much water I'm getting. That is what I require. I don't want any other. So likewise, the data, whatever you are giving, it should be proper. The main advantage of the supervised learning is that to allow you to collect the data or produce a data output from the previous experience. Okay, so the drawback of this model is that decision boundary might be overstrained if your training set does not have examples. So the drawback is if you're not having any previous example or any previous experience, so the algorithm, whatever is developed, it is not properly, it won't give you suitable information or suitable or accurate results. Okay. As the best practice of supervised learning, you first need to decide what kind of data should be used as a training method. This is what is very, very important. You are supposed to practice first what data to be given for supervised learning. Okay, so these are basic references what I've considered. So some activities when just when you are looking after supervised learning, it is always targeted with the continuous target variables if I'm having, or categorical target variables I'm having. Continuous target variables if I'm having, I'll be applying regression techniques. Categorical like yes or no concepts, there I'll be applying the classification techniques. Okay, so some of the examples: house pricing predictions and medical imaging, like that. So this is the basic activity. Now it's going to be the question time. I think I have delayed a lot, 10 minutes delay. So do you have any questions? You can switch on your speaker mics and just let me. Any more questions do you have?
So any participants, if you are having any query, please unmute yourself and you can ask your query to the sir directly. That is done. So hello participants, if you are having any query, so you can just put it in chat box or you can ask directly to the sir. So there is one question in the chat box, sir. How to take GeoLand based data set? Is this freely available?
GeoLand, pardon? I can't see the chat box actually right now. Yeah.
So how to take GeoLand based data set? Is it freely available?
Yeah, it is freely available. But anyway, Dr. V Murlikrishna sir is going to take the next lecture. GIS applications, machine learning concepts. He is going to explain. So definitely he will help you. I know him very well, but he don't know much. I'm sorry, because he taught various subjects to my friends, and they gave me complete information about him. Okay, he's very good friend of my friend, so I know him very well. Okay, so definitely he's going to help you out in this particular zone of geo information, because he's having much experience in that particular area. Okay, so if you're having any other questions, please, all the participants, please forward the questions to my mail ID. I've already shown, that is crsgirao@gmail.com. Okay, so any other question, Dhananjay? Guru Prasad?
No, I think there is no more question from the participant end. So, sir,
Thank you very much, Guru Prasad, for giving me this opportunity. And once again, I would like to thank all my faculty members. And please, being a faculty, when we are teaching the learning methodology, most of the time we adopt it is deductive learning. Okay, so in the beginning, I said inductive, deductive, and transductive. So normally we apply deductive technology for learning mechanism. And with this, I would like to thank each and every faculty member who participated here and who considered. Okay, thank you very much. Thank you for giving me the opportunity. Thank you.
Sir, before the vote of thanks, our department, head of the department, Dr. Dayanand, sir, want to speak to you. Sir, over to Dayanand, sir.
Sir, good morning, sir. Am I audible, sir?
Yeah, audible, sir. Please.
Good morning, sir. Good morning.
Very good morning, sir. please.
Good morning. Thank you very much, sir. It was a wonderful session. I was listening completely to your session. You started very well.
Yeah, I tried a lot. Actually, this session, I need a 3 hour session, but that's material, whatever I submitted, I just quickly I reduced the work because people should know as much as possible under supervised learning. That's the reason I have reduced. Thank you for giving me this opportunity, sir. Really, it's a great, wonderful job.
It was really a wonderful session. No?
Thank you, sir.
Thank wholeheartedly from the Computer Science and Engineering Department that you have accepted our invitation to be a resource person for this particular.
Thank you, sir. I always accept because that is my college. I always proudly say that it is my college. Okay.
That is true, sir.
Yeah, thank you. Thank you very much.
Once do visit to the college, sir. I invite from the department side, sir.
Definitely we do, sir.
In spite
Yeah,
of that,
definitely, sir.
also do visit, sir. It is very near, sir, from Hyderabad to be there. Do visit and.
Yes, sir. Thank you very much, sir. We'll do it. Okay.
Yeah.
Thank you
So
very much.
let me have a vote of thanks. We are very thankful to our prestigious alumni, Dr. C. Rama Sheshagiri Rao, sir, for very highly impactful, productive, and knowledgeful session. So we are highly delightful for your presence as a resource person. So and also invite you to visit our campus, sir, once again. So thank you so much, sir, for your knowledgeable talk. Thanks once again from the department as well as alumni cell of the GNDC.
Thank you very much. Thank you very much, sir.
So, yeah, sir. Thank you so much, sir.
Thank you.
So, dear participant, with this note, I end up this session. So the next session will be started at 11:30. Please join at 11:20 a.m. So it will be by Dr. V Murlikrishna, sir, who is a very renowned person. So please join early to listen him, to listen such a great personality. Thanks to one and all. With this note, I am signing off. Guru Prasad here.
So actually, yesterday also you are joined for the inaugural session, sir. So thank you very much for joining that inaugural session also yesterday, sir. So thank you, sir. Thank you. So I'm very fortunate to read out just the few points about this Murlikrishna sir, because if I have to read his complete biodata, I think it will take more than half an hour for me to read his complete biodata, sir. So it's thank you very much, sir. So I'll just read out for my audience, like just let them know that what you are and what is your contribution to the research. Sir. So, sir has completed his MA from IIT Madras and PhD from the prestigious institute, that is Indian Institute of Science, Bangalore. Sir was Dr. Rajaraman, a distinguished fellow at the Defense Research and Development Organization, that is the DRDO, India, and the national coordinator for the Geospatial Public Health, which is the National Networking Government of India project. Sir was the editor and a member of the editorial board of the several S&T journals. His present research focuses are on the open innovations, artificial intelligence, and geospatial data analytics. So, and geospatial population and public health management. Sir was a professor and a founder, head of the Center of Spatial Information Technology at GNTU University from 1990 to 2005, and a director of Research and Development Center from 2005 to 2008, again at GNTU Hyderabad. So he has served as a guest scientist at a German Space Research Institute, that is a DLR, and GKSS Research Center. So, sir has also been working as a consultant to the various projects in the area of the geospatial data analytics and its application to the environment, horticulture, agriculture, hazardous waste management, etc. His research interest includes the geospatial technology, data analytics, digital image processing, open innovation, currently working with the design thinking and the lean management, research methodology, remote sensing for the natural resources, environment, and disaster management. Sir is presently continuing as a director director at the Indian Academics Program, Independent Projects on Innovation and Business Analytics, Smart Village Management, Smart Village Movement from 2001 and still continue. So we are very fortunate to have you on this occasion, sir, as a resource person. And I myself is very eager to hear from you a session on the machine learning and applications in the GIS. Along with me, I think all my participants are also very much eager to hear from you, sir. So without taking much time, I welcome you all on behalf of the Computer Science and Engineering Department, Gndecb Engineering College, and all the participants who have been registered across the India for this AICT, IST, research, that AICT, IST program of this 1 week, sir, on machine learning with the Python. So thank you, sir, for accepting our invitation and joining as a resource person for this program. So it's over to you, sir, and please, you can carry on the session now, sir. Thank you. Thank you, one and all.
I think we are going to become shortly good afternoon within 25 minutes. So still it is good morning only. So greetings to all, and I'm extremely grateful for the kind words mentioned by Professor Dayanand, head of the Department of Computer Science at Guru Nanak Engineering College, one of the engineering colleges which I happen to see also at AICTE and MHRD, doing a lot of committed work in research, etc. First of all, let me have clarity. Are you able to hear me, Professor Dayanand, sir, and others?
Yes, sir. I'm able to hear you, sir. Yeah, we are able to hear you, sir.
Okay, then. Thank you. Thank you very much.
Yes, sir.
So, as mentioned by Dr. Dayanand, we'll be just sharing our experiences, our views, and the contributions of some of my research scholars during the last 2-3 years and some more than 10 years back, what exactly happened with reference to GIS in general, with specific application to geospatial analytics, essentially. So the machine learning, artificial intelligence, and GIS, some of the topics. And somebody is making noise. I don't know who that is, but can you just, yeah, maybe you can monitor. You can see that anchoring of the mic. You can ask them to mute. So is it okay now? Is it okay now?
Yes, sir. It's okay, sir. Yes.
Okay. No, if you can monitor the participant list where the mic is flickering, the noise is coming from there. That's what it says.
Definitely, we'll monitor it. So we'll
okay, I mean, that's all. I hope it's not coming from my side. I want to be sure. That is the only thing. So I'm just looking into my mobile phone. It's not there. It's nothing. Switch it off. Thing is happening there. Okay. So coming to the issues. I mean, you have had, I think it's the second day, and most of you had expertise in various issues like in computer science and engineering, and also the peripheral areas in like where image processing, satellite data analysis, statistical techniques, stochastic processes, they all get converged when we talk about the geospatial analytics, because geospatial analytics is an area which is transdisciplinary. It's not multidisciplinary, it is transdisciplinary. So that is what exactly is the concern, how we can take up this area in a more meaningful manner. Basically, because you are probably, certainly more or less heard about, not probably, definitely heard about machine learning during the last one day until today morning, and earlier also. Many of you may be experts, and I hope I'm not carrying cold to Newcastle, because talking to experts, I'm a bit nervous. So essentially, we talk something related to issues, how the geospatial data analytics is emerging and how GIS can get benefited by the developments in the technology. Because AI is providing tremendous opportunities, as you are knowing about it, because essentially ML, machine learning, gains a lot of experience through repeated observations and builds a model for new situations. That means you have a historical data and diagnose the data and predict the behaviors. That is the essential stuff. So while doing these things, how these topics, how those issues could get benefited is the issue. I don't want to concentrate more on AI and ML, because you're having a series of lectures on these issues. But I would like to only draw AI and ML, which is relevant to such an extent where your AI ML, or what are the Python libraries that can be used in conjunction with geospatial tools, technologies, so that geospatial technology can get benefited by these issues, both for prediction and prescription. So these are the issues. What we actually have today is much simpler and much more narrow deep learning that can do some very specific tasks. We'll see these things, and these are all my points, which I'm just thinking at the beginning, and whether we can address these points, whether we can solve these problems, whether we can specifically focus the technological domains on these issues is a major concern. So what does this mean to us? What does this mean to us is one important issue, because the AI and the access basically to big data together is providing a lot of techniques in all areas, and there is no area where the geospatial technology tools have no application. because AI, machine learning, the deep learning and techniques along with the cognitive computing, and these things matter a lot when we did work in the area of health spatial data management. So where we are moving, how we are moving makes a lot of significant difference, because in machine learning, the one of the important things is, as I see in machine learning, essentially performance is usually evaluated with respect to the ability, with respect to its capability, with respect to its accuracy to reproduce known knowledge, while tools like knowledge discovery or the other one is data mining, the key task is to discover previously unknown knowledge. So these are the things, and as machine learning is a subfield, what we call it as, for various issues, data science, with a subfield of data science, with a focus on designing specifically algorithms that can lead from make predictions for data. I'm just giving the definition of ML in a way suitable to apply the GIS. I'm not addressing what ML has been defined by so many people, so many experts in AI and all these things. But I have drawn those experiences from ML and see how they are relevant when I am applying GIS, geospatial technology, because it is a type of ML is a type of AI which allows the software applications to become to bring more accurate predictions, outcomes without any sort of explicit programming capabilities. So basically, this is one specific issue where we can address things and how we can move forward, where exactly is the things happening. So what does the machine learning is missing here? What is the machine learning actually learn? So we all know we have a set of data, X, and a set of target values, let us call as Y. So we want to determine or to learn the function that relates X versus Y, so that we can automatically iterate, develop by any method to learn this function by using statistics. So that means it is essentially a minimized cost function, a loss function. That means you are trying to be closer to the reality. That is what exactly. That means in simple terms, a function f such that it maps to y, where x are the features are independent variable and the target is the dependent variable. So here y is equal to mx plus b by some sort of let us say curve fitting or a regression or whatever you are all familiar with. M and B can be create a line that will best describe the relationship between X and Y. How do we know these are close? That is, we cast a loss function, positive function, etc. So accuracies, etc. So these are the things that make a lot of difference when we are trying to move forward. Where exactly is the issues? So thinking in these terms. Pardon? Yeah. So some more points. What is artificial intelligence? I'm not going to explain to all these things. I'm not bringing you aware of what are all these issues. So AI, ML, data analytics, big data are related and dependent on each other. If so, what? Then ML is a machine learning algorithm, historical data. We all talked about these things. So where exactly these things are going to help? How these things are going to make a lot of difference? Because GIS, as we all know, there is the periodic table of spatial analysis. Spatial analysis is one of the very, very critical issues, and because there is a need for it, and the issues are need to be addressed in some sort of a specific manner, whether it is vector layer, vector conversion, or raster conversion, image calculations, etc. These things make a lot of significant difference. So how the tools of GIS, which we are going to talk in detail a bit later, at this time are ideal for machine learning. See, not that the issues are like classification. You want to classify. Basically, the geospatial technology is the technology which started utilizing a lot of data. Today, affectionately, with all the affection, we call it as big data. So big data is some sort of a new issue today. But geospatial technologies, the remote sensing, satellites collecting petabytes of data since 2 or 3 decades, a lot of data is available. There are definite challenges at that time to address this data. But while doing these issues, how the geospatial informatics, GIS, is trying to draw information on the satellite data, whether on the land classification, other one is change detection, the other one is related to road networks and the enhancement of the resolution, 3D modeling, and coastal applications, etc. So if you want to do some sort of a spatial kriging, there is no tool as good as geospatial analytics. Geospatial analytics can provide you enormous scope, enormous opportunity to take things much, much forward. While thinking in these issues, where are we? Because essentially where we are talking is applications of geographic information system. Before that, we'll say supervised learning. I'm not going to again explain to you because the 2 categories of machine learning, which are very, very significant. One is supervised, unsupervised. There are other things also, semi-supervised, reinforcement, etc. We'll see those things also separately. Because we essentially apply the supervised ML techniques when we have a piece of data that we want to predict or explain. That is what is the issue. So prediction is possible with machine learning, but prediction is not sufficient for me. I want prescription. Can we go for prescription? So prescription is one of the most important outcomes of the geospatial analytics. There is no other, according to me, there is no other analytics that can give a prescription as a meaningful solution. So whereas ML is giving prediction, AI, ML, DL, they are all giving a prediction one way or other. But geospatial analytics helps you prescription. Because if a cyclone is a meteorologist based on the last 20 years data predicts the cyclone is going to hit in the south of Paradeep and Orissa coast, let us say. But that is not sufficient. The issue is what are the measures, what are the interventions that need to be taken, how this information can be used, how these tools of machine learning join together in GIS and geospatial analytics can be brought down so that we can have a prescription. This is the solution to address this particular problem. Those are the focus points in which my students, my team are working on prescription analytics, because the prediction and prescription are very, very common issues where we can take about it makes a lot of difference. Because the predictive analytics is a machine learning very, very successful is because of the availability of large data sets. The data is the key. Without data, no tools of data analytics can perform. See, for example, AI is almost 20, 30 years old. When I was doing my research in the Institute of Science, we used to talk about AI, but nobody has taken it forward at that time. But it has come now forward because of the ability and developments, which you are all familiar in the hardware and software and storage, data storage. These are the 3 things that are made responsible, which were not there 30 years back. That is what exactly, because the hardware architectures such as GPUs replacing the CPUs has provided a great opportunity for anybody to work to move forward. So these are the issues which I think are very, very significant, important. So what is geodata? Yeah, geographic data and geospatial data refers to data and information on the location relative to the Earth. The geospatial, when I say spatial location, what is happening is a general phenomenon. Where is happening? Why is happening? How is happening? Those are the three questions can be answered by the geospatial technology. Because what is happening can be done by a typical satellite image can give you, but that will not be sufficient because where is happening and how it is happening and why is happening. Along with the cultural themes which we are shown here, administrative data, socioeconomic data, transportation, etc., and physical things like elevation, environmental data, hydrographic data, those are the very, very significant issues. So while doing these things, let us just spend a couple of minutes on what is the GIS. Many of you may be experts, but for the benefit of one or two people who may not be aware of what is GIS, let me share my own understanding of what is GIS, because GIS or geographic data is basically a sort of a system, information system. It is an information system to work with data referenced by the geographic coordinates. The location happens to be very significant. In simple words, GIS is both a database with unique capabilities for spatially referencing the data, also a set of operations for working with the data. So GIS has the ability to serve as a database system, also a data analytics system. That is the unique characteristic of GIS. It's not just a simple database system, but it's also a database system. So it will consist of a specifically hardware, software, and procedures designed, some sort of procedures designed to support the capture, manipulate, analyze, model, and display of spatially referenced information for solving any sort of complex problems and management, planning problems or the management problems. Because a GIS is an integrated package. GIS is an integrated package with the ability to input, store, and analyze and output the spatial information. That is one of the most important. Basically, GIS is a telescope as well as a microscope and a computer. I call this a telescope, also a microscope, and also a computer. Or even it could be a Xerox machine also. So see, so many things are tied up in a system, definitely in what you call a GIS, where things are happening, how things are happening makes a lot of significant difference. Basically, when we go for before that, because you all doing AI and ML, the core benefits of AI are basically within the supply chain. Supply chain makes a lot of difference because that is the very critical, crucial thing for any developmental activity, whether it is inventory management or some sort of a improved safety conditions or reduction of the operational costs. That is where the AI has got core benefits in supply chain. Supply chain, I'm just quoting because that is the key for any developmental activity. That is what happens today. Pandemic is there for the last 2 years. What is the sector that is influenced, impacted most? Leave the individuals, cases, diseases, etc. That is one important, very important thing. If other than this, what is the next one? Next second one, casualty, is the supply chain. Supply chain drastically got impacted. Can we think in that direction how these tools of ML can be applied? AI, a subset of which is ML, DL, which is subset of ML. All these three, how these things can happen, can implement, can predict, can prescribe along with the GIS. So this 1.5 hours of my talk cannot make me to learn anything new, but I'm just trying to share with you what are the salient features and what are the areas in which, as a IT professional, you have to look beyond the borders. Today, the borders between different disciplines, philosophy and computer science, psychology and computer science, botany and computer science, they all got blurred. And now today we're talking computational XXX. That has become the order of the day. So the geospatial analytics is a mixture of satellite data, image processing, location analytics, geointelligence, and IT. So while doing these things, so what are the GIS analysis functions? We have to look into the GIS analysis function. Spatial analysis functions distinguish GIS from other types of information. I already told you the ability, the spatial analysis, no system, no technology, no tool, no method other than the geospatial based algorithms can go for spatial analysis, because it is a typical information system which goes for spatial analysis. That is where the strength of this entire system lies. And that is where, when those GIS and satellite image applications started almost 30 years back, the developments are not taken forward, mainly because it has not entered into the mainframe system. Now it has entered into the mainframe system because of the developments in the resolution of the satellite. Because today the satellite resolution, it was in 1972, the first Earth resource technology satellite launched by Americans has the resolution of 80 meters. Resolution also, I'll explain what is resolution. It's the smallest size that can be seen on the Earth, 80 meters. But as you move forward, today we are having resolution of, for the sake of 80 meters to 80 millimeters. We are moving forward slightly. It's not exactly 80 millimeters. For the sake of rhythm, I said 80 millimeters. So it certainly 30, 40 centimeters is there, but it's not, day is not far to have 80 millimeters as the resolution. So while doing this, is it the case of technology push? We have got eminent experts in area of IT, satellite technology, and image processing capabilities, etc. Is it just to satisfy their trust for knowledge? We are launching the satellites. We are using the geospatial technology. We are imbibing artificial intelligence and the geospatial artificial intelligence, which we are defining right now. Is it the purpose? No. We want to integrate all these technologies and bring more effective, more prospective analysis capabilities for addressing the national problems, whether it is in our own country or the global problems, whether it is in natural resources, infrastructure, disasters, these three things which are making the life of the individual, the society, the country, the people, making more what you call as bad. So how we can address this? What type of interventions that can be made? So because the geospatial AI can give a prescription. It's not prediction though. So instruments predict, instruments give the data. Doctor predicts what is going to happen because of the biochemical, the blood test, the other 2D echo tests, cardiac tests, all these things. It's not enough he predicts. He should also give a medicine. He should prescribe the solution. Otherwise, he's not a doctor. But here, the geospatial artificial intelligence is the doctor because he prescribes the solution. I'm going to underline this particular point every time. Maybe in the next 1 hour, I may say 20 times, because this is the most important contribution of the geospatial artificial intelligence. The prescription, whereas general artificial intelligence and these things have got greater affinity for prediction, lesser affinity for prescription. Because prescription is always location based. And location is always possible only under the geospatial analysis. So what are the geospatial analytics that are make a lot of difference here? So the types of geospatial geographical data analytics here you are seeing here. Descriptive analytics. You are all familiar with this. You are already doing this. So that tells you what has happened. Diagnostic analytics, what has happened. So the value and difficulty, the less difficulty here, what has happened. By looking at the data, you can always say what happened. And you can also say why it has happened, some of these things. And also you can predict with all the models, machine learning, linear regression, neural networks. You can predict what will happen. The next important thing is the prescription, because the predictive analytics, how a particular thing, how particular phenomena is going to disrupt, either positive way or negative way. For example, take a supply chain, because supply chain is one of the most important things in these days of pandemic. All technologies, all research has to concentrate on supply chain. Whatever may be the parameter, it could be a vegetable or a medicine or a industry products, how they are getting influenced. Because having a robust, strong supply chain forecasting system means the developments or the business equipped with resources, with those resources, or the intelligence to respond to emergencies rather, becomes a very, very important thing. Because as I was telling, the pandemic had a substantial negative effect on supply chain. How we address these things makes a lot of significant difference. Where we can go for, how we can go for, so makes a lot of differences. Because the prescriptive analytics, which is my key focus, describes a set of analytical capabilities. It describes a set of analytical capabilities that finds some sort of a action item to meet a defined objective, a predefined objective. Let us say that one. So it could be maximizing the revenue, or it could be providing resources, etc. Because prescriptive analytics and optimized methods such as linear programming, the other one is rule-based decision-making system, or heuristics, they play a very significant role. See, this prescriptive thing differs from the descriptive analytics. Please note it, prescriptive analytics is not descriptive analytics, or diagnostic analytics, or predictive analytics. Is here, we are looking at some sort of an output which we go for a meaningful thing. Here, in all these things, I also say the important role, though it's slightly outdated, so out of the context, but let me mention basically the IoT. IoT plays a very, very important, because it is a dedicated physical object, a system of physical objects that contains the embedded tools to communicate as well as to sense or provide any sort of interaction. So IoT also plays a core building block in these systems for digital processes or digital platforms. So we are having a lot of mixture of so many issues here. It's not just a simple system where you give some data and get the output. And the data sources are different, data techniques are different, the needs are different, and the algorithms are different. So while doing all these things, how we can integrate these things makes a lot of significant advantage differences. So maybe when we're talking these things, we may have to see what are the important functions of the GIS. So maintenance analysis of spatial data, maintenance and analysis of non-spatial data, integrated analysis, prediction, prescription patterns. That makes a lot of difference. Actually, my students have made, let us say, some sort of a quick presentation for these things. So it goes moving fast. So I could not, I just noticed it 1 minute back. I thought I cannot do it, but I'll only go for these things. What are the emerging issues with remote sensing and JS. So the tools and analysis make a lot of significant difference here. Basically, you will see here. I'm not going to put in a, yeah, we'll see. So the map overlay and intersect. These are the tools. Nearness analysis, diffusion, network analysis, measurement, attribute analysis, and interpolation. So these are the things we talk in different domains. And what are the emerging trends? Attribute analysis. Attribute analysis is because you may have a polygon. What is it? Is it a lake, or is it a forest? Is it a building, or is it a town? That is attribute analysis. And geospatial analytics include deep learning, because a lot of data is available today with the satellites, and how the data analytics can prosper with the input layer and several hidden layers and an output layer. So because the weightage function, diversity, and the techniques of application make the deep learning very, very significant application. Because while we are talking about these things, the significant application is the most important application in recent years, I call it, is which is surpassing, which is exceeding human accuracy, is image recognition, and also image classification. That is where the intersection of AI and GIS and is creating massive opportunities, because machine learning, and I say machine learning, it also includes DL, the core component of a spatial analysis in GIS. Ultimately, these tools are the algorithms can be applied, and you can use any sort of algorithms to process. It could be a clustering, simple clustering, unsupervised data, a clustering. What is the meaning of the clustering? It tells you the large quantities of categories available in the data, and identify how you can group the data into several clusters and separate them in a much more meaningful way, because you can apply separate from the noise. That is what exactly I would like to say. Whether it is the prediction algorithms or the geographically weighted regression. That is one important application which we have done for a prediction of the COVID cases. But still, of course, the model is not very effective. But I will share with you for some time, because the geographically regression, but geographically weighted regression. So what is happening in Delhi? What is happening in Bombay? What is happening in Kerala? The same thing is not happening in Chhattisgarh. So though geographically weighted regression can be there, but geographically weighted regression factors can help you give the ability to model the spatially varying relationships. Here I'm telling the occurrence of the COVID cases, the pandemic. So this is one area where the geographically weighted regression has got greatest scope because of its significant difference. So the deep learning is one important issue. So because the deep learning has become doable, I said doable, is because of the availability of data, then availability of fast computing facilities, and also algorithms. That is what exactly, because the researchers have now done some sort of most challenging phenomena on the deep neural networks through some sort of algorithmic improvements as well as network architectures. So these are the things that are addressing over period of the time. Maybe I'm addressing so many issues because I want to bring the total concept where happening, what is happening, etc. And how do we think about these issues makes me one of the um, what you call as um, enthusiastic person in these domains, because we are working in GIS, remote sensing, image processing for the last 30 years. But the amount of support, the amount of clarity, the amount of accuracy that is obtained when we are using analytics by integrating the tools of broadly AI, in focus with the deep learning, are very significant. And though uh, these are not quantitated, applied very clearly, but there is difference. So now my message, my request to all the IT professionals is, please think in your own, you are all becoming experts in the data analytics, focus on ML and applications, etc. Now remove the borders with GIS technology and bring it into your main fold and apply those things and try to go for prescriptive solutions that are needed in the society. We need a technology pull, not technology push. Technology push means that whatever I know, I'll give it now. Technology pull means what type of technology that is needed by the society. That is what exactly makes a lot of differences. So dimensionality of data, the environmental mapping, hyperspectral. Hyperspectral is it is a great example of big data, because multispectral satellites will provide 4, 5, 6, 7 bands of data. The electromagnetic spectrum, 400 to 500, 500 to 600, or 700 to 800 nanometers of the electromagnetic wavelength. That is in the visible, near infrared, and microwave part of the electromagnetic spectrum. But hyperspectral, what happens? It divides the visible region and near infrared region, number of channels. Where my multispectral has got a bandwidth of 100 nanometers. Here the bandwidth is only 10 nanometers. So that means you have got more data, more precise data. What is happening? Like you want to observe what is happening or a phenomena once in a month. That is multispectral. What is happening every month, every day, 365 days? That is hyperspectral. That means if you have the hyperspectral, if you are observing every day, you have more data. You have more opportunity to see minor changes. So that is what is the hyperspectral. So ultimately, this happens to be very, very significant. And you may need to go for tools like techniques like dimensionality analysis, etc., and image fusion, which are slightly away from this particular presentation. So these things make a lot of difference when we want to give full benefits of the data analytics to the society. Because the data analytics profile, I'm a bit biased. You may say, I'm also agree. Data analytics has no use, has no relevance, unless it gives much more valuable, much more significant, much more timely, needed prediction, prescription of a solution based on what is happening. So that is what exactly is the issue. Classification of GIS here. So GIS helps you in mapping as well as analysis. See, the low analysis capabilities are here for automated cartography and geospatial analysis, high capabilities, low mapping. Geospatial analysis doesn't have mapping capabilities, low. It has got low capabilities, but very high analysis. But geospatial artificial intelligence. So we want to have high mapping capabilities, high analysis capabilities, high analysis capabilities. So these are the things which I term here the geospatial AI. So the geospatial AI integrates the location knowledge, image knowledge, and the tools of machine learning for both for prediction, study of the data, diagnosis, then prediction, and also prescription. Prescription is possible through the location advantages. So this particular combination of classification of GIS, I consider is one of the most significant issues. And this is where the IT domain has to concentrate for applications, for the students' projects, etc. Because most of your student faculty, they are teachers. So you should think in that direction by integrating your, what you call as your capabilities with other departments. You have a mechanical department, you have a metallurgy department, you have a civil engineering department, you have an environmental department, you have a physics department. You bring the scholars from there and give your tools, because no technology, no tool, no IT has use unless it is used. So, because as a technology person, you are all giving technology, let it be done more effectively. So, what are the two important data models? Data, we're talking about data and two important data models. One is the vector data and the raster data. Because vector data and raster data make a lot of difference. Ultimately, the any other issues, we'll see these details also subsequently. We'll see these details also subsequently. Ultimately, what is happening, etc. So I'll say here, GIS, drone mapping, and artificial intelligence. Because see what happened in satellites. Ultimately, um, when the satellites were launched in 1972, somebody is. Can you mute, please? I request you kindly mute. I don't know if somebody is questioning or talking. That's why I get confused. So machine learning in GIS. I lost already what I'm talking earlier. Machine learning has been a core component of spatial analysis in GIS. And with the classification, you can use vector machine algorithms to create land cover classification systems. So we are talking about these issues now. So basically, we're talking about it. Geographically weighted regression gives the ability to model spatially varying relationships. Half-done examples I'm just showing here. What happened here? The geographically weighted regression data for prediction of occurrence of the COVID cases during the last 20 months time frame. So the coefficients, etc., are there. This is a choropleth map which gives you how things are moved from good to bad over a period of time. That is what exactly is the issue, how confirmed cases have moved forward, and what exactly is the issue. How we can use this geospatial data, occurrence of the satellite data, occurrence of the cases, as well as the tools of what you call as machine learning, supervised learning, or unsupervised learning, or reinforced learning. These are the three things. In between also comes semi-supervised learning, a combination of supervised and unsupervised. How these things could be happen. So here we can see here, because you have a satellite image, this is a satellite image. How you can use the data analytics to detect an image, to find an image, and as well as its location. That is what makes a lot of significant difference. While doing those things, basically, because once you are able to use the tools for classification of the image, features in the image, it could be especially in automated manner. So it helps you a lot for the government departments which are involved in development, planning, etc. in terms of anomalies, in terms of feature extraction, or infrastructure mappings. So while doing these specific issues, who is providing you the data? The satellites. So what is the extent in which we get the data? Because satellite data is a very, very, is the heart of the geospatial analytics. Today, when I say this satellite data, I put in brackets because the drones have come, which are almost replacing the capability of the satellites. The satellite in the Indian Space Research Organization may not accept it, but I am also from Indian Space Research Organization originally. But I today say drones are providing accurate, timely, as needed, need-based data, unlike satellites. Only difference is satellites are launched by the government and drones are launched by the individual. So that is the difference between those two things. But it's not the question of drone or satellite, but I'm talking about remote sensing image. What remote sensing image is providing? What remote sensing capabilities are available? What capabilities are needed? That also is very, very, because for that, once we understand the data availability is, as a data analytics person, I thought I'll spend about 5 to 10 minutes on this particular issue, where remote sensing can play a very significant role. So spatial resolution, so in 80 meters is the resolution, and today we are moving better than 1 meter. So that is what happened, because The resolution 80 meters helps you to map only big features, that is spatial resolution, whereas 1 meter means that means you can identify features on the ground from the satellite which are size of 1 meter. That means you can see many features. That makes a lot of difference. So ultimately, that is what exactly is a specific issue. And spectral resolution, I already told you spectral resolution, hyperspectral, multispectral, number of bands. That means instead of observing a phenomena once in a month, observe phenomena every day. That is the spectral resolution. Temporal resolution, time, how much time it takes for the satellite to come back to the same spot, how much time that it takes for your drone to cover the data. So that is what exactly is the issue. So while doing these things, now we are talking about, you can see, get a feeling of what is meant by spatial resolution. Here the pixel size is roughly 1 kilometer. Here the pixel size is 1 meter. You can see 1 kilometer and 1 meter. You can see here that the Rajpat from India Gate, President Rashtrapati Bhavan, track which is very clearly seen. So in this image, we are seeing only a small part, that is 1 meter, but in 1 kilometer data, half the size of the country can be seen. So 1 kilometer, 380 meters, 23 meters, 188 meters, 5.8 meters, 1 meter. So this makes you to analyze, appreciate the importance of the geospatial data to tell what is happening here, but where is happening, you need higher resolution. So this high resolution data has really changed the way the remote sensing data can be utilized and provided greatest opportunities, particularly in the area of infrastructure. Countries' infrastructure mapping. Today, World Bank or any government planning requires a geospatial approach for any program, whether it is construction or development or manufacturing. So that is where exactly is the issue are involved. While doing these things, there are polar orbiting satellites and geostationary satellites. It's enough if you know. Many of you may know about it. The polar orbiting satellites, which we are talking, most of the remote sensing satellites are polar orbiting, whereas geostationary satellites are mostly communication satellites or other satellites like what you call as geostationary satellites, weather satellites, meteorology satellites, otherwise, are the communication satellites. So image classification becomes a very, very significant element. So today, earlier technologies are not providing very great things. Today, support vector machine, because support vector machine is a machine learning technique. It's one of the very, very powerful technique that takes the classified data and looks at the extremes through the hyperplane. Because it draws a decision boundary. One of the important things in support vector machines, which is very important according to me, it draws a decision boundary line based on the data, and the decision boundary we call it as hyperplane, and the data points that the hyperplane margin pushes up are called the vectors. So what is vector? Support vector is the data point, and what data points are there? That side of hyperplane, this side of hyperplane are the support vectors. Because the support vectors, because why I'm telling is many of you are aware of support vector machine for your image classification. Its relevance when you're talking about the ML and GIS, I'm just telling, because it's important. There are the very important data points which are close and also opposing. Essentially, you put the support vector machine training samples, let us say it could be a tree or a grass, and try to classify the difference between these two. And these are supervisor classification technique. Then other technique is, which is familiar with many of you, is the image segmentation and clustering. They call it K-means clustering, because K-means clustering is a very popular method. By far, so far rather, the K-means algorithm is one of the most popular methods of clustering the data. You ask anybody to cluster the data, you'll use the clustering, because In K-means, what you call as the segmentation, the unlabeled data is grouped into number of groups, some sort of a technology. So in this unsupervised classification, the K-means algorithm first segments the data, and the segments the image for further analysis. And once you have the ground truth, it becomes some sort of a supervised classification. And kriging is one of the important things. I'm just giving some points out of hat, because as it comes to me, I'm just giving somebody who is going to pursue these things. Please think in that type of Bayesian kriging. It's not simple kriging, but Bayesian kriging, because the kriging interpolation predicts unknown values based on the spatial patterns. Ultimately, whether you want to study the pandemic, etc., it estimates the values of the variable. Unlike the conventional kriging, the Bayesian kriging simulates at least some sort of a local models, and it has been proved it is successful, many of the things. And the deep learning and the training happens here very, very significantly for any sort of development, for any sort of application, for any sort of evaluation. So while doing these specific issues, where we can go, what we can do makes a lot of difference. All this time you are seeing how the satellite is going around the Earth. So continuous acquisition of data, all these things you are aware. I will skip these things. So now satellites which are providing information. So when you want to go for machine learning application along with the GIS for a specific theme related to the natural resources or infrastructure, one must be aware what are the satellites that are available. So don't bother about any of these things. The resolutions, see 0.5 meters, 0.4 meters, 0.46 meters, 0.3 meters. 0.3 meters you can see on the ground from a distance of about 800 kilometers in the space. That is the technology that has developed. So these 30 meters enablement moved from 82 meters in 1972 is that today the food in a plate, the food is given in a plate, we have to eat it by developing algorithm technologies to detect the object, to process the information, to disseminate the information. So that is using the tools of support vector machines, ML, under ML, and also the deep learning with the big data technique. Because today big data architecture is one of the very, very significant things. It has become very popular issue, very powerful issue where we are handling. See, whether it is a case of batch processing or stream processing, because data sources are different, and big data has got a lot of importance, and the data source, satellite data, is the biggest big data source in the world, I can say, to any country, any region, anybody. So while doing these things, we'll see what is spectral signature. Spectral signature means how the feature reflects the incoming electromagnetic energy coming from the sun into the space. So you can see here, this is a spectral signature of vegetation, forest areas. Here you can see the snow, water bodies, Manasarovar here, etc. You can see the resolution is 55 meters ultimately. That is what exactly is a phenomena here. And this is Myanmar coast in Bengal, and the eastern part of India. And this is Kuwait satellites. See, the idea what I'm saying here is how we can use this data in a more meaningful manner, and how I can detect the features. That is not possible with the conventional image processing techniques, because you need a lot of ground sampling. You need a lot of classification accuracy based statements like maximum likelihood. No, it will not give the values which you get by using artificial neural networks, deep neural network, or RNN techniques, because the accuracy, the features which you can identify for automated image classification are, I mean, very high order. So that is where the tools of data analytics play a significant role. Absence of data analytics, if the satellite data not to use anything because it has not provided good values, good meaningful outputs. Today, the data analytics, AI, ML, DL, the same thing which I'm talking about last some time, are providing greatest opportunity to study, to delineate the footprints of the objects, each footprint. That is where exactly is the issue, where things happen. And this is one area where the drinking water mission has taken place. How do you map the groundwater prospects, biodiversity information, then natural resource sensors 10 and 20. So 10 is a conventional data application, but this is a tool which has been used, neural networks data has been carried out. This is again a conventional map of land use, soil map of a district, resource map of the district, and resource map of the geomorphology of the district. And all these three things are combined to develop a composite land development unit. That is where the GIS stands for. The GIS gives you unique capabilities to integrate the data, to integrate the values, integrate the information. And this information identification, feature recognition, and putting in a plate and to be delivery is possible through the analytics. What is happening? See, the information, the data is provided by the satellites. The capabilities are provided by the geospatial data platforms, and the tools of data analytics, neural networks, or other techniques of supervised learning are providing greatest scope to identify those features. Because here we are talking about the features, the geospatial artificial, which combines spatial science, artificial intelligence methods into machine learning, data mining, high performance computing to extract knowledge from geospatial big data. That is the, so full of jargons. Simple thing in simple words, lot of data is available for the last 30 years. No data has been analyzed because lack of algorithms, lack of tools, lack of technologies. But today the data analytics in general, data science in general, data analytics in specific general, and AI within specifically machine learning, still specifically deep learning. These are this hierarchy of data developments. These are providing unique capabilities which are not possible earlier. And the research community need to concentrate with more efforts on utilizing the satellite data and meeting the needs of the country rather. So that is not exactly the issue. You can see a simple deep learning technique is used, a footprint technique by training about the same image, how the swimming pools are there, etc. Within residential parcels, how many houses have got the swimming pools? So that is the type of technology that can be seen here. So building footprints are extracted out of the satellite image, footprints, because once you identify the footprint, automatically it helps the government for planning the property tax, etc. The validity, developmental, etc. So here the deep learning techniques have been used for detection of the roads. You can see here simple classification technique here is used to classify these things. So this is a IRS image of Mahabubnagar district in Telangana state, and you can see delineate the water bodies, water body density map, stream network, digital elevation model, etc. and forest risk information system. So while doing these things in a conventional manner, how you can use the tools here for the specific technology. So there is the forest here. How do I use the analytics to find how much of area has changed over a period of time? So rectified image is here, and rectified image is here, and this is how the data difference image has been obtained both by conventional techniques as well as the techniques of, as well as the techniques of some sort of neural image processing techniques. So while doing these things, how these things can happen makes a lot of significant issues. So while we talked, started with the GIS, and when we're talking about GIS, we said about the issues of use satellite data. Then after the satellite data, again, we are talking about the data points, data models. One is a vector model, the other one is a raster model. What is a vector model? Vector model will contain points, lines, and polygons. That means a point can be an electric pole, a building, or it could be a lake in a larger scale, or in a smaller scale, it will be a polygon. So a line, it could be a road, it could be a boundary, it could be a railway network, etc. And polygon, any area features. Those are the polygons issues. So while we are talking these things, this is a real world situation. This is a real world vector model. These are polygons. They described the building, the lake, and these things. But this is a raster model. Raster is a grid. Here you are seeing reservoir, same reservoir, settlement. You can see lake. You can see. So here resolution makes a lot of significant difference. I'll skip these things because there's still not much time is there. Basically, most important thing, if you understand here, is the resolution makes a lot of significant difference. So because for any analysis, you must know what is the ability of detection, recognition, identification, and description of the feature on the ground. So that is what you train the system, your machine, you train the system so that it can learn the features by providing. This is a table to essentially train the system. A radar occupies this much area, a bridge occupies this much area, like that. So you can see, identify all the features you can imagine on the ground and try to build up a lookup table of sizes of the features so that automatically the system learns. So vector data model, raster data model, and pin model make a lot of difference. You can see here, this is a point, building, a line, a road, a lake is a polygon. This is how it is represented by the, that means a lake has got coordinates 6, 5, 9, 5, 11, 3, 8.2. So that means how the data is stored in XY domain. The lake is stored with these 4 coordinates, whereas the road is stored with these coordinates. The building is stored with these coordinates. That's point, line, and polygon. These are the 3 ways, the features which store the data in the vector format. The other one is the raster format. So this is vector format, other one is the raster format, and topology. Topology means explicit relationship, it will mention who is your neighbor, etc. So these things are not important at this point of the time. So it tells you this is a polygon. Here, B is the polygon, and what are the arcs? 1, 6, 8, 5. The 1, 6, 8, 5. These are arcs is bounded by this B polygon. That explains the topology. So what is it and who are the neighbors? That is what exactly what matters in a GIS system, GIS environment. So this is a raster model is again different. Raster model is not coordinated, it occupies the grid, matrix. First column, second row, first column, third column, third row, like that. The features are identified. So a vector and a raster, this is how they are represented in a single line and a grid form. So I'm eliminating so many things here, basically because of the time limitation. I'm not going to address these issues here. The triangulated irregular network is a very, very significant developmental application, significant issue, significant need for anybody to work. Basically, that is what exactly makes a lot of significant differences. While talking about these issues, what we have done is essentially we need to classify, we need to work in a different significant manner. Basically, because well, earlier I just recollect now, sometime back we said about the image classification. Image classification What matters image classification here? Because there are many approaches for image classification. A simple thing is a rule-based approach, and the other one is a data-driven approach. That is what exactly is a machine learning. Not a rule-based approach, a data-driven approach. The other one is, of course, the ensemble methods, which are not we're not worried about it, and the reinforcement learning approaches. So these are the 4 approaches for classification. A most important way you can classify an image, a feature, is to say it again, a rule-based approach. The other one is data-driven approach. Third one is ensemble approach, and the fourth one is the reinforcement learning. So basically, these things make a lot of difference when we're working on the data models. So here you are seeing the vector model, raster model, etc. While doing these specific issues, where we are moving, what is happening makes a lot of significant difference for any applications. So this is a comparison between raster model and the vector model. And here you are seeing here. Now let us come. So we have seen how we have moved forward. We just highlighted certain issues and how things have moved forward in terms of applications, in terms of data models, how the data analytics play a significant role. Data analytics give value to satellite image. Data analytics give purpose to satellite image. Data analytics give utility-oriented output information for the satellite image. Earlier, these things are manually done with low efficiency, but today the geospatial big data is more extraction and analysis of information from huge volumes of data. Machine learning is more using input data and algorithms. That is what exactly the difference between geospatial big data techniques as well as the other issues like that. So machine learning, I need not tell you here, you already know the specific issues like supervised learning, semi-supervised learning, unsupervised learning, reinforcement learning. Just for my own recollection, I kept it here. But the most important thing I want to say here is we wanted to what algorithm. See, we have here so many things: image classification, diagnosis, linear regression, and classification, clustering, regression, etc. Clustering. All these things are happening between unsupervised and supervised, etc. Real-time analysis and reinforcement and learning, all this. But today, when we talk about here, the supervised learning, semi-supervised learning, unsupervised learning, or the reinforcement learning, we need what type of features that are good for analysis of the features on the ground. Because satellite image has got a very, very significant information. So if you want to use supervised classification, yes, regression gives you our decision tree and classification. We have seen these three things just now, how the classification techniques have helped, as I already stated, a rule-based approach or a data-driven approach or an ensemble approach or the reinforced learning approach. So this you are seeing why you want to classify cluster, because I want to know from the satellite image what are the features that are happening with a specific issue and what are the points where a lot of forest fire is occurring, forest degradation is occurring. So I want to do some sort of clustering, because forest fires you don't have any information, that is unsupervised. Whereas supervised, you want to develop an urban area or a rural area, an agricultural area, use regression and decision trees. So dimensionality reduction, because you get a lot of data which has got redundant information. So dimensionality reduction, what makes it? You may have 20 bands of data. You need only 4 bands of data, which is independent, which contains in the 20 bands data overlap. So remove all unnecessary overlapped information and remove that dimensionality reduction. And Markov models, etc. They help a lot in these issues. So considering these specific developmental techniques, developmental activities, where we are moving, how we are moving, makes a lot of significant difference. Where is the issue? That's a significant difference for any other issues when concerned with the development. See, we are talking about C, C++, you are all familiar, and this particular program, as I see, is specifically related to the Python, and you are already familiar with some sort of Python, but it has got some unique libraries which illustrative, because we are not exhaustively doing, we are certainly trying to see what libraries of Python are used, are being found in a infrastructure, transportation, in agriculture, in environment, waste management, etc. So these are the programs that are being projects which are being handled by research community. One is forecasting of population urban planning, environmental e-waste management, river hydraulics, reservoir management, groundwater modeling, urban hydrology, structural health monitoring, transportation, finite element method, structural analysis. So when we are talking about the geospatial tools, essentially it addresses three issues. One is disasters. Geospatial tools are meant for three things. One is disasters. The other one is infrastructure. The third one is the natural resources and environment, whatever you call it, combined. So the focus is on all the geospatial means these are the three areas where we need to work, where we need to develop the phenomena, where we need to concentrate on specific issues where things can happen. Ultimately, because the developmental things like ESRA has done significant developmental works on applications related to the geospatial mapping, geospatial analysis, etc. So while talking about these issues, let me say a few illustrative research areas. Flood risk and prevention. It is not a civil engineering problem. It is a problem in which application of data analytics to the terrain. Terrain is a three-dimensional model which is available as a database, geospatial database. So the geospatial database, along with the past data of the flooding, a big data source, let us think about how we can apply what is the risk, what is the hydrology, what are the floodplains, what is the sustainable drainage system, how we can mitigate the flood risk. So you have prediction and also prescription. This prescription is possible because of the ability of the geospatial terrain data. Because terrain, the three-dimensional terrain which you get from satellite data provides you excellent information. And how these things happen makes a lot of significant difference for any issue, for any program, any task related to development activity. Because I just happened to see how the Python is applied for one of the American universities has applied on the corrections for atmosphere on the top of the atmosphere from the landsat data. Python has been utilized. And then most important thing is the digital elevation model, because digital elevation model is a three-dimensional model of the Earth, and basically the three-dimensional model in Python. That effort which we are working, we are not still successful. This effort is to show how to automate the DEM files by downloading SRTM. SRTM is a US database, shuttle imaging radar based terrain model. So while doing that, this can happen essentially. How can you predict spatial data with machine learning? So that is what exactly is a specific issue. So Python happens to be it's not that it is the only thing. Lot of usage is being done. It has got an excellent amount of libraries, which you have seen here. Basically, the type of libraries it has got. These are the things which you are all, I'm sure you must be working with so many of these libraries. And these libraries have got unique capability to address whether it is a building information system or application of a neural network or issues like flood management. Machine learning algorithms discover patterns in the data. AI and artificial neural network algorithm is used to predict runoff. That is what we have done. Runoff means the flood. How much, if the rainfall is there, take the past data, how much of rainfall has created the urban floods, and how the runoff is flood. Runoff is flood. How do you can predict for future if the meteorology department says next week it is going to rain 60 centimeters in Karnataka, in like the Hyderabad Karnataka region, in Gulbarga region, then what type of floods it can create is a typical geospatial analytics model, which requires the spatial data and the machine learning tools. So it is a very good needed model. Every education institution should concentrate on that type of developmental applications. Basically, because the specific methods or the insights, the data can be exploited and used both for quick and accurate data-driven decision making. That is what exactly is important concept, important application for anyone to deal with the issues. While doing these things, so the techniques play a very, very significant role. So I was telling the data, because data happens to be the crucial thing. There is no data analytics, there is no machine learning, there is no AI, there is no deep learning without data. So they all dependent on data. They all come because of availability of the data. The data has been collected lying idle. Somebody thought, how can I use the data? Then the tools of AI have been revived because you've got a lot of processing capabilities, you've got storage capabilities, you've got high performance systems, you've got CPUs, advanced CPUs, come GPUs. They're all enabling an excellent environment to utilize the data to derive meaningful solutions. So GPS, satellite remote sensing, aerial surveying, radar, LiDAR, the IoT sensors, digital cameras, RFID network. So these are all the things providing excellent data. While talking about these issues, while talking about specific these things, where are we? How are we talking makes a lot of significant difference. Because when we do these specific issues of the geospatial analysis, because GIS, let us understand, is a core component, is the most important component of any infrastructure maintenance operations. And also GIS plays a very, very important role by integrating the technologies and the infrastructure and the project life cycle, thus reducing the both time and the expense cost, let us say cost. Also, this shows, there are very good cases which are shown the ROI, return on investment, in terms of the savings of the project cost is almost anything from 10 to 70%. There are cases in which the returns of investment are as high as 70%. So that is what exactly, which is very, very substantial, considering the scale and the total investments involved. See, the satellite data, which I call as a big data, which is nothing because it has got a lot of volume and a lot of velocity and variety, and techniques for dealing this data are very, very significant, and it raising new issues, how these things can happen. That's the GIS serves as a holistic technology. GIS serves as a holistic technology, I consider it as, to analyze almost every aspect of rural or urban information, economic development, and environmental protection rather, or Other one is SDG, Sustainable Development, etc. So the emerging computer technologies like AI, IoT, and ML are allies of, I call it, are wonderful allies of geospatial technology to bring a nice transformation mission. That is what exactly is the issue. How these things can happen, how these things can move forward, where these things can move forward makes a lot of significant differences. How they basically, because we are talking the issues very significant manner, how we can move forward, how we can take things essentially in a more operational and significant manner, where these issues basically can take things, because whether it is descriptive analytics or the diagnostic analytics or the prescriptive predictive analytics or the prescriptive analytics, it makes a lot of differences, lot of operations. Why this? Because we are talking about the Python, because Python is popular. Why it is popular now? Basically because it is a very, I want to call it a wonderful language. It is a useful language, more accessible programming languages available, because it has got simple, very simple syntax, not very complicated. A non-computer professional like me also understood Python very well, which gives you a lot of emphasis on natural language. That is what exactly important. Because so let us take the library NumPy. It supports dimension analysis, if I recollect properly. Then the other library is Pandas. Pandas is useful for information, for I think it is for handling any missing data. Useful for, basically it helps you to go for any missing data to address the issues. Useful, it provides the missing data. That means in sort of a kriging, whatever method you're talking about. And the other one, this one provides you so how data visualization can take place, how you can go for visualization. And very important thing, the Python standard library is some sort of a extensive suite of modules. I can say the extensive suite of modules. I'm not able to use many. I find many things are useful, but we are trying to explore the purpose of each module, how it can be used. We are trying to become some sort of an atlas, how each module can be applied in geospatial artificial intelligence application. Because each module which comes with Python is understood very well, and there is what is called, if I remember, there is a Python package index, which has got many additional Python libraries. So while doing these things, some sort of analytics is sort of process of exploring and analyzing large data sets. We are talking about analytics. When we say analytics, we are trying to do that type of analysis, that type of approach, where we are talking about significant application. Take even TensorFlow is a Python library which invokes, I think, C++ or something, which I'm not very sure. And there are cloud systems, etc. So machine learning in Python is a wonderful program being organized by the Guru Nanak Engineering College, because that is the need. Because we need ultimately a method to implement. We may have a lot of theory, we may have a lot of data, we may have a lot of analogies, lot of requirements, but how do you deliver it in a plate? That is possible through this program of Python, because everybody knows what is to be done. Everybody knows how to do it, but very few people are doing it. And this sort of program application, coming to the realities, please think about Python libraries for data analytics. Python is the most accessible programming language with simplified syntax. Please go for it. Make an exhaustive, each one of you, when you go back, try to spend a year with about 10 students on the library explore and try to make a very well referred and what you call as encyclopedia of Python and its applications. Python means I'm talking about libraries, because what type of library I need makes a lot of significant difference ultimately, because where is what is where, ultimately that is what is important. Okay, I want to go for dimensional analysis or numerical computing tools or linear algebra or Fourier transformation. That is possible with NumPy. So what are the techniques required? What are the libraries that can do? That is requires a lot of importance, because there are so many libraries which need uh, to be evaluated and taken forward, and you can go further of the capabilities of the each thing. And most important thing is, I'll say, the missing data. The missing data can be some sort of a added using when you are doing big data, the pandas library. So we have to validate. I'm not saying supporting any of these. Each one has to be validated for our own meaning, for our own issues. So 5ML algorithm for geomorphology, random forest was the preferred classifier, ANN decision tree, random forest, support vector machines, mapping of mineral prospects, random forest give better results in most of the cases. So these are the observations of some of our small programs. And geography big data challenges are modeling the geological big data, technical issues must be addressed. I view here that these challenges described here make good topics for research within the field of AI and big data management in geography. Geography means, yet I don't say geography is a discipline. Geography is not a discipline. It is the mother of sciences and technologies. It is the house for knowledge. So ultimately, we have to apply the technologies to sort out, to address these issues in a significant manner. How we can take these things forward is summary train things in big data analytics and GIS. A technical algorithm software based on the intersection of big data analytics has to be set, and we are working on these issues and specifically taking forward. IoT device also provides a lot of data, and this watershed GIS, etc., provides specific intelligence techniques wherein how the artificial intelligence approach for hydraulic problem. So that means we are trying to link with some sort of pizza and not. That is example I will give something. So you have to think out of the box. Orbit shifting innovation. Those are the two important things as an innovation person. I say, don't stick to your own domain. You have got the unique capabilities with state-of-art training in Python. You start exploring these things to various problems in the society, which are coming in a greatest manner in the issues. So your future is yours, and you have got wonderful scope to apply these things. Thank you very much.
Sir, thank you, sir. Thank you. Am I audible, sir?
Yes, yes.
Yeah. So thank you, sir. It was a wonderful and lifetime memorable session which was delivered by you. And this is not my feeling, sir. I think this should be the feeling of each one of the participants who have listened for your session, sir. Sir, big thank you, sir. And I think these many days I used to hear a lot about you, why you have been so respected among the research scholar. And I think today it was just a glimpse that I have seen from you, like how much of the depth of the knowledge you have, what type of contribution you have done to the society, sir. Exceptional, sir. Words are not there to say. Express my happiness to you, sir. A big thank you, sir, because it was a wonderful session where in your started with about this use of this AI and ML in GIS, then about the emerging trends in the GIS. Then you also talked about the student projects, how it can be taken up by the interdisciplinary faculties so that it can give the better results, because you need the knowledge of the machine learning, you also need the knowledge of satellites, you need the knowledge about the earth. So interdisciplinary project, definitely. That's a very good view that you have been expressed, sir. And apart from that, you also touched about this open source programming languages which are being used. And we also thank you, sir, because to you for allowing the topic that we have chosen it, because it was the AI and ML, that is machine learning with the Python. So we never wanted to have just the theoretical concept. We also wanted to link it with this implementation, and that's the reason, sir. I'm very happy to inform you that for every day, almost all the sessions in the afternoon, they are on the hands-on experience with this Python, sir. So definitely one step we are going ahead. Apart from that, sir, you also discussed about the various machine learning applications which can be used in the GIS. So a big thank you from the Gndecb Engineering College, Computer Science Department, and all the participants who have witnessed this wonderful session of remote sensing and GIS, how this machine learning can be used. So on behalf of Computer Science and Engineering Department, sir, I invite you once, if possible, do visit our campus, sir. We'll be very happy to receive you at our campus, sir. And thank you very much, sir. And thank you one and all, sir. Thank you.
Thank you, Dayanand, for your kind words. My only feeling is these type of programs we organized by you should motivate the faculty who have come here to transfer these things into projects by the students. That is the goal.
Yes, sir. Very true, sir.
Thank you. Thank you.
Yeah, very true, sir. And the moment, I think this is the personal, the moment you are given the confirmation to Dhananjay, sir, like you will be delivering a session. So on that day onwards, I was very eager and I felt very happy, sir, on that day. Like, and that day onwards, I was eager to hear from you, sir. And today it was a day, sir. It was a memorable session, sir. So big thank you, sir, from the whole CS family. Thank you, sir. Thank you, one and all. Thank you, participants, for the patience listening this session. And I hope that all of us will join again at 2 o'clock. Yes, sir. Please, sir. Continue.
My apology, because I have to go to I have another meeting at now at to go to the airport actually.
No problem, sir. No problem.
I asked
Okay, sir.
the
Dhananjay, sir. Yes, sir. He was telling it, sir. Yes. Yeah, yes.
So, but any questions are there? Certainly, I love to answer those questions because the questions make me to learn more. I always
Yes,
look
sir.
at the questions
So,
as a
yeah.
source of learning.
Yeah,
I always believe life is learning, learning is life. So
yeah,
that's what exactly.
that's
Thank
true.
you, then.
Yes,
Thank you
sir.
very much.
True, sir. I think I request the participant, if you have any queries, I think you can send it to our FDP mail so that we can forward those questions to sir. So that way we can do it, sir. Done, sir. Thank you, sir. Thank you, sir. Okay, participant. Then thank you. Thank you, one and all. Thank you, sir. सर ये रिकॉर्डिंग स्टॉप करो